Welcome to our events, everyone. A special welcome to our viewers on YouTube live streaming. I'm Hero Yoon from MIDAS IT, your host for today. We have around 300 attendees who registered in advance and about 1,000 people joining us online. Okay, to kick off our presentations, we have Mr. Alecs Yoon from MIDAS IT headquarters, who will deliver the opening speech today. Please welcome him to the stage.
Good morning, everyone. I'm Alecs Yoon, Overseas Business Director of MIDAS IT headquarters. It's a pleasure to welcome you all, MIDAS Square 24, which is our special technical events for MIDAS users and all of civil engineers. Welcome to those attending in person here in Kuala Lumpur, KLCC, and as well as the engineers joining us online from Singapore, Hong Kong, and Malaysia, and also the Philippines. Thank you for joining us. As we begin this event, I would like to share our goals and the reason why we are here to support the civil engineers. After we started developing MIDAS solutions and software in 1989 in South Korea, MIDAS has grown to become a global presence with over 1,000 employees and 20 branches worldwide. It's truly remarkable, and we recently opened a branch office in Bangkok, Thailand, and Sydney, Australia, and also we are excited to bring our solutions and services directly in Malaysia in the near future. MIDAS solutions have been applied to both historical and everyday structures that form an integral part of our life. And I want to take a moment to express our deepest gratitude to all the civil engineers who have dedicated their efforts to ensuring the safety and integrity of our society. And your hard work and commitments are truly invaluable. And we are dedicated to supporting the civil engineers by offering many chances to learn and grow through our training sessions and the meetings. And we aim to build a community of skilled engineers, and which is advanced field of engineering, especially in Asian countries. As MIDAS IT has a hands-on experience in engineering design, we focus on practicality and strive to develop the products that satisfy the engineers' the practical needs. And we are very happy to have the opportunity to share our newly developed solutions and services in MIDAS Square 24. And I'd like to extend a special thanks to 3 presenters who will be sharing their design experience and knowledge today with us. Mr. Alecs Chong from Oregon, Hong Kong, and Mr. Tzyy from HNT Malaysia, and Mr. Abinales from Philippines. These people are truly outstanding engineers. I'm also very excited to listen to their lectures. Once again, thank you for attending MIDAS Square 24. I hope you enjoyed today's sessions. Thank you.
Yeah, thank you, Mr. Alex Yoon, for the opening speech. So from now, our first presentation will begin. The first presentation is from Mr. Tzyy Wooi of HNT Consulting, who will discuss the application of MIDAS Civil Annex for Rail Structure Interaction, so-called RSI, in a Malaysian project. Let's give him a warm welcome, please.
Hello, thank you, Hiro. Hi, good morning, and salam sejahtera to all my respected engineer, particularly in Malaysia, who are sitting here. And thanks for the MIDAS invitation, and it's a great honor for me to become a speaker and present some of these engineering topic, or we can say that it's sharing together with all of you. All right, this morning I'm going to present on this RSI topic, which is a real structure interaction. Particularly in this Malaysia project. So the content of this presentation, we have two parts. The first one is on the design concept. The second part is a real structure interaction analysis. So why we need the RSI analysis? So actually RSI is just to determine the interaction between the base structure and the rail. So particular on the railway structure, our white duct structure is actually supporting this rail. That's why there's a need for us as an engineer, maybe it's a structural engineer, maybe it's a track work design engineer, to examine or to get this feel between the interaction between the rail and the base structure. So definition of the long rail. So particularly in this what we call new modern technology, we prefer this long rail, all right, because of the advantages. So those days we are in maybe the past 40 years or 50 years, all the rail is a short rail. We can see most of this rail expansion, those days during my childhood, I always can see this kind of rail expansion. But coming towards to the new modern technology, the rail expansion joint has been improved on this left-hand photo. Of course, with this long rail, you have extended, improved the passenger comfort by reducing the impact force acting on the rail, particularly on this rail expansion joint. And of course, reduce the environmental disturbance factor by reducing the noise and vibration caused by this impact force on the rail expansion area. So you can see some of this derailment or the rail buckling. Of course, when using the long rail, then it will become important for us to determine this stress, allowable stress in this rail to avoid the buckling when the temperature rises, of course fracture when the temperature drops. So this is a kind of graph. Actually, it's not new. Actually, it's extract out from this UIC code or all others reference. So sorry, just now long rail is the definition is more than 200 meters long. We call long rail. All right, just now I forgot to mention. So this is quite a typical kind of a graph you can see in this UIC code or all the reference. All right, so particularly you see how the temperature will affect or impact this rail by this additional stress inside this rail. We come to this design requirement stresses. I believe some of my friends over here, they are quite expert actually for the rail bridge design, and this definitely is quite norm to them, to you also. So we have two limits of this stress. One is on the compressive stress, one is on the tensile stress. So, and of course, we have two criteria. So far in our rail technology, there is a two-track system. One is on this gravel ballasted track. The other one is we call concrete track, or we call track slab concept. Basically, there's two types on this track from. With this compressive stress, this actually is allowable, additional allowable stress from the structure to the rail. All right. So we have this on the ballasted track. We have 72 MPa with a radius more than 1,005. When the radius reduces, then the stress will be reduced on the permissible stress. On concrete track slab, you have a go up to 92. Of course, this one is you have to refer to this UIC recommendation. If you refer to this UIC code, they only mention 72 for this ballasted track. For tensile, it's 92 for this ballasted or this track slab system. So one of the criteria is the stress, just now we mentioned. Then the second criteria is on the deformation. So we have this, actually, we have a few criteria. I mentioned here is only, always wrong button. So one is a relative displacement limit, which is between the rail and this deck. Is maximum is allowable is 4 mm. Actually, we are talking about not the figure. Actually, physically, 4 mm is very small value, 4 mm. So second requirement is absolute the displacement of deck due to braking and traction is plus minus 5 mm. And the third one, this one is on this ballasted track, provided there is this what we call expansion device, then you can go up to 30 mm. If your rail is continuously for how many kilometers long, then this one is not applicable. Another deformation criteria is not about the end rotation of the deck. So we have this 8 mm criteria. So that's why all this one will be criteria for us to determine in the RSI analysis. Route to be considered. Of course, RSI, we have focused some of the root cases, not all this root action we need to be considered. The first one is force attracted by the rail and the resulting additional axial rail stress due to the combined effect of temperature. The first one, actually, the main action is temperature. Vertical load, which create the bending, and subsequently will create this additional axial stress to the rail. And of course, it's a braking and traction load. So this is the main three action need to be considered in RSI. Longitudinal relative displacement between the deck and rail under this load effect to ensure that the stability of this ballast in the bridge or track set also. So for the bridge, force and bending moment attracted by substructure, including the pier column, bulkhead, and the pile. And this will, of course, the behavior of the structure, all right, the bending, displacement, rotation of the substructure will affect this rail in the RSI, which will create additional stress to the rail section. Right, so temperature load, if follow the standard, you can see there is a real force, all right? So if your length of the CWR expansion zone and this at the two end is about 150, then it will reduce. So at the center, you can see there is a maximum. So some of the stress in this literature document, will show you this one. So this is what we call the brief zone, the two brief zone. All right, thermal load or thermal action. If all the span in the bridge of a CWR, CWR stands for continuous welded rail, thermal load are applied to only the bridge stack. Yeah, all right. So if refer to this UIC 774-3. Now in the Eurocode, the current Eurocode already I'm not so say it's a copy or what, but it's all the information of UIC requirement already inside this Eurocode. You can see it, this one from the Eurocode too. If the rail expansion joint are present on the bridge, then thermal load are applied to both bridge and rail. So there is a difference. So a lot of sometimes engineer confused. So for the applying the temperature, of course, we are not in 4 seasons in Malaysia. So we normally not encounter this problem. So for the bridge, we have a plus minus 20 degree. Of course, along the way, in Malaysia, a lot of engineers, why they argue that, well, not plus minus 10 degree. All right, so there is some interpretation from others engineer along the way. So, but this UIC is requested plus minus 20 degree on the bridge. Steel bridge, depending on your climate in your country. So you have to do some research or this background study to get this temperature range in this steel. So if you really go through this RSI analysis, some of this say multiple span of bridge, you can see that you can see the stresses on the compressive additional stress due to temperature load will be like that on this screen, and then this tensile additional stress, these two, okay, due to temperature, and this right hand figure is due to the train routes. So basically, the stress pattern will be like that if you already have done this RSI for multiple span bridges. Of course, this important sometimes is just to want to verify this RSI result or modeling is correct or not. So somehow or another, due to this complexity of the bridge, so we normally will not validate this RSI modeling and result. Actually, this one is important for us to verify your modeling whether it's done correctly or not. So by the substructure, due to traction and braking, of course, our substructure will resist all this lateral force or even the transverse force. All right. So, but in RSI, basically we deal with this traction braking force due to this train route. Of course, vertical train also create the vertical force to the structure. We have a few cases, 3 cases. One is a pure compression. The other one is a pure bending. And the last one is the interaction between the compression and bending. So with this behavior of our structure, due to this vertical load, will create these additional stresses in the rail. Basically, it's due to the rotation, on these bridges. So as I mentioned just now, we have a vertical braking and acceleration load. Vertical braking and acceleration is based on the train running over the bridge. So it depends how many span of a bridge you are consider. So of course, some of the basic kind of routing is a high-speed rail or general rail or client specific kind of routing you can consider. But basically, for this LM71 or high-speed rail, these forces you need to consider. But of course, it is just an example for all of you only. Yeah. So you go to this particular project. So it depends on this client requirement. So you can use back this routing to check. So this is quite a typical. If you're familiar with this, what we call this railway traffic routing. This LM71 routing. Some is SW0 and SW1. So this all is an equivalent route to be considered inside this ISI, unless you have a very project-specific routing. Perhaps you can use that instead of this LM71 and so on. For high-speed rail, the request is on the LM71. Combination of the root case effect. Actually, thermal, you create this routing or displacement, actually. So for calculation of the total support reaction, in order to compare with the global stress in rail with this permissible value set by this railway, the global effect of this thermal, all right, so you'll be this formula, all right. So this total, not only thermal, traction and braking, and together with the train vertical route. So the factor will be used is 1. All right. So when using the computation analysis method, the interaction due to traction braking route and the train vertical route can be separately computed. So it's up to this designer or engineer to model and to execute this RSI. It's quite a free hand for you to do it. Actually, there's two types of analysis if you are not realize it. So first one is a simplified separate analysis, which is you separate all this root case, thermal, traction braking, and train vertical route separately. And the other one is called complete analysis. That means you combine all these three together. All right. So simultaneously, so you can get this complete analysis in stages. Maybe you can model it as a construction stage together, inclusive in this RSI analysis. So it's dependent on global structure system. All right. It's important. The separate analysis is more likely to produce a greater axial force than the complete analysis. So what it means is, actually, if you consider this root case individually, so your tendency having this exit the real stress is higher compared with this complete analysis, which will combine all the root cases together. Well, any other factor which will affect the real stress is also the long unit, we call the real grip stiffness, or we call longitudinal resistance of the track. So basically, we have, you see the graph is quite, can get it from this UIC code or Euro code. So for this track, actually rooted and unrooted, there is a different kind of resistance, longitudinal resistance. So because of this one, it makes the analysis maybe more complicated when you consider the rooted and unrooted, because they give you the different resistance. Okay, so unrooted is 40, rooted is 60. All right. So of course, reference one, if you see, you have to do this stress check using this unrooted case for the ballasted track, you have to do this using this action to check these stresses. For reference to actually if the decision test has been performed, a separate validated specific value can be used. All right, this is for unrooted. For rooted, you still go back to the 60. All right, Newton per meter. All right, so this gives you the overview on the just now I mentioned, right? For example, unrooted and rooted cases. All right, for the unrooted, you can see that unrooted condition, this is a stress, all right, due to thermal or whatever action, and concrete track slab unrooted condition, this is the result. Okay, this is typical. Also, it must depends on your global structure behavior also, but typically you will get this kind of trend of the result. It's a quite typical result. You can see that for this what we call the unrooted and rooted cases, all right, for this ballasted track, you can see that this rooted condition will give you higher stress. Similarly to this concrete track slab, all right, so rooted condition will give you maybe compression is higher. All right, tension maybe is quite similar. So you can see that the concrete track slab, so compared with this ballasted track or gravel ballasted track, will give you 30% higher for the concrete track slab. This kind of range, it's not like cast in stone must be 30%. It's a give you general idea is it will be higher. So of course, another factor is the length of the bridge, of course, right? So just now we say the stiffness on this stiff grip on the rail. The second factor is on this length of this bridge. Of course, you have a longer bridge, definitely the induced stresses to the rail will become more. So it depends on this length of this bridge, all right? How you model or how you determine your bridge length also will affect your real stress inside this as a additional real stress in this analysis. So of course, in normal circumstances, we say that the long span bridges we need to perform the RSI. For typical span like simply supported, we are not required because it's quite confident that the stress will be within this allowable limit. So you can see all this length will be affect this what we call the stress inside the rail. You can see the 60-meter steel bridge. All right. So let's say you have a fixed point at the center. Perhaps you can go to 120. So it's not require any rail expansion joint. UIC it gives you some simplification to this designer. For this concrete, all right, maybe you can go up to 180, as provided that your fixed point is at the center. All right, if you're single span, then maybe you need to check again. So basically, I think 90-meter span. If your structure is stiff enough, perhaps you don't need this rail expansion joint. So this is a graph or maybe the study on this type 1 and type 2. Actually, sorry. This is type 1, I forgot. Type 2, type 3, and type 4. So it depends on the length. So you can have a kind of a similar result. Okay, the stress type 1, you can see 26.2. Unrooted, rooted is higher, 35.07 MPa. For type 2 is 11.45. And this rooted condition is 16, close to 16. Type 3, 26, 36, and type 4, 21, and 30 for this rooted condition. So you can see that the length will affect the real stress. So in summary, type 3 will give you the highest stress. All right, this depends on length. So just for everyone to look at what is this length will affect or impact the real additional stress. So on top of it, of course, this span length, like since this train vertical also, just now we talk about the temperature, traction, and braking. So of course, on the vertical force also, on vertical train road action, so this one will create the kind of a rotation on this bridge due to this bending. All right. So of course, the longer span you have a 10 of rotation is higher. But of course, it depends on the stiffness of your bridge. All right. Compared with box girder and the normal beam and slab, even with the same span length, maybe box girder give you a higher stiffness. So the stress will be reduced, okay, compared with the beam and slab. So it must depends on this stiffness on your girder also. So not only the span length, but the stiffness of the bridge. So of course, the substructure also play an important role. All right. So if your substructure is very standard, all right, and free to move, not say free to move, is no restraint to move. All right. So this also will affect the total behavior. Perhaps sometimes a lot of engineers argue that, hey, I have a more flexible kind of foundation. Is this good or not good? So it must depends on the overall, because you're not only checking on the real stress, but you have a deformation criteria to meet also. So you're too flexible also will create the problem on the real, not only this stress. So some study has been done. A lot of engineers, particularly like structure or white engineer like me, and we do know the structure, the base structure condition, boundary condition will affect the rail. So we thought this one is a highway bridge. All right, it's a highway normal bridge. We try to get as much as longer we want, so that to eliminate this expansion joint for the bridge. All right. So but in this railway bridge, all right. So because it's supporting the rail, so with this system, you apply the same concept from the highway bridges to the railway bridges. Maybe we create indirectly. All right. So to this rail become where this rail expansion joint is required. More rail expansion joint required, that means more maintenance is required, and the comfort of the ridership will be affected. So some study, this is a kind of typical span. Of course, in the typical span also, they have a lot of this boundary condition. It will be much depends on our structure engineer. We like fixed, free, free. There is a lot of condition to share with you. You have all fixed. I think this one we seldom use. All right, if you use this, no point to go for simply supported bridge. Okay, we have a FMM. All right, this kind of configuration. Of course, fixed move. M is move, allowed to move lah, so it's free lah. So you have this configuration, particularly in our bridge normally is like that, one fixed, one free, one fixed, one free for simply supported. We have a MFM. Okay, we make the things continuous, not simply supported. So this one maybe also, but we still seldom have it. And of course, you have a fixed M, free, fixed, this kind of configuration. And last one, you have this three-span configuration, fixed, free. Particular normally for the long span, three-span configuration. So normally we have this, the last one. So perhaps let's say now we have a three-span, we have one monolithic pier at the intermediate support, then maybe we have a free, free, this kind of configuration. So all this one will affect the result on the rail. So let us to see what is the difference between these two, or this 6 method. So just now we have a case one, we make it 30 meter. All right, expand. So we have a FM, fixed fee, and this is MFFM. All right. So, and the case 2 times 30 meter force span. All right, with this configuration. So this is another type. Oh, wait, go back to the first slide. Oh, I think few slides is missing. Oh, sorry. Perhaps maybe never mind. So I just want to tell you that for this type of condition of the support, which will affect this real stress a lot. So you have a fixed MM, this configuration, you see the stress is 54. Compared with this MFM, all right? Sorry, compared with this these two cases, MFFM is 28, and this free, so you get 38. So in summary, we can see that the fixed free configuration, or if you want to have a 2 span, you have to do this kind of configuration. All right. So to get the minimum additional rail stress in the rail. So try to avoid this kind of the configuration for the in your bearing configuration. All right. So this is a few. Maybe I missed one slide. It's all right. It's just to get you the have a hint or guideline how we configure this. Never mind, it's all right. Go back to the slide. Then we come to the second part on the rail structure interaction analysis. So the first part is talk about this design criteria, permissible this stress or deformation limit in the UIC code. So now we talk about some of this analysis in the RSI. So typically this figure, when I explore to this RSI analysis, first day, this figure is quite famous, but I don't know where I get it already. So it may not in UIC is some kind of reference. You can see that how long, if let's say your white is very long, how long your modeling need to be to represent this accuracy of this analysis model. So this guideline to say that, let's say we have a long span, structure 3 span, all right. So at least you have another 5 span left and right, typical span. This is like kind of a minimum requirement. So you can model longer, which may give you more accurate result, but perhaps maybe the difference is not much. So this is a kind of a guideline only. Those day one, these are those quite old figure. So for this engineer, at least there's a guideline. Cannot be shorter than this. All right, 5 span minimum, left and right, after or before the long span. So then how to model this what we call RSI in this analysis software. So you have to model this all the element, rail and bridges in this beam element. Ballast or this thread strap is what we call elastic bilinear. Sorry, just now I'm missing this on this not only the stiffness of the real grip, but the permissible, the movement of this grip for the balasted and thread strap is different. That's why we had to use this bilinear elastic link to link this rail to this structure. So element length is 1 to 2 meters, but particularly I will use 1 meter because then we come to this rail, the system or platform engineer or contractor. Normally they say the rail grip is 1 meter or 600 to 1 meter. So normally I also try to use this same spacing so that no argument with them later on how accurate this modeling. So you have to communicate with this rail supplier. So what is the spacing on the rail? Okay, in normal circumstances, all right. So but recommendation is about 1 meter to 2 meter. To me 2 meter is a bit too long, all right. So there is some figure on how you model this RSI, how to connect the rail to this deck. Okay, so between the expansion joint and this normal bearing type, spring type, or it's embankment. Embankment also you have a soil stiffness and everything. So this give you the overview of how you model this bridge with the rail on top of it. This particularly is on this UIC code. There's one long table for you to calculate, all right, basic specification on this one span bridge, all right. So with the embankment 300 meter long. So this kind of a tabulated result in the UIC code. This is to verify. Actually, basically, it's a verify the result of this computer analysis. So the UIC give an appendix after this UIC 774-3. So they have a series of appendix. It's quite lengthy appendix for engineer to verify back the result. So in the MIDAS, so there's a kind of maybe user interface for the routing. So if you're familiar with the MIDAS, I believe so, all of you here. So this is like input on this RSI. I think this one is using wizard, RSI wizard. So you have this temperature load, as I mentioned, tracking and acceleration braking. Of course, vertical load, you can use a moving load data, but it's not so straightforward also, actually. So to validate this RSI result, perhaps maybe you have to model the very simple one, similar to this UIC code, to make sure that your result is similar to your what we call UIC result. So once you have this validation done, which is plus minus 5%, that means your modeling is quite accurate. So you can use the same concept to expand your need. All right. So beforehand, definitely you need to validate, because I believe all of us, if you have a same project, 10 engineer model it, I believe 10 engineer also give you the different result. It's how much the different only. So to give you the guideline, to validate this analysis, perhaps you need to do this validation. All right. So at least this result is within plus minus 5%. This is a kind of UIC, how you put the routing and blah, blah, blah. So with this temperature plus minus 20 degrees, with this stiffness and this limit of displacement. Actually, this is for this ballasted track. Unballasted track, maybe you can go back to this recommendation in UIC. I believe it's a 0.2 mm for this track slab. So this is, of course, we need to input all the property of the rail. and this bridge step property. So this depends on your project. All right, but for the rail, it's quite standard. Let's say you use this rail section 60. It's quite standard. So then you compare the result. As I say, you use this sample from the UIC condition. You check with the RSI result. All right, if your result, say for example, let's say for this example, we get 31.87. All right, due to temperature, and UIC result is 30.67. Okay, quite close, actually between ±5%. Similarly, on this whatever all the combined stresses, all right. So you can see it's a 151 here compression. If a put result axial stress on the due to temperature had load applied to the bridge stack is excluded, the value come to 119.7. That means your 151.57 subtract the result just now. 31.87, so you will get this 119.7. So this match the UIC result of 126. Not say matching is within this ±5% limit. So all right, so maximum stress depending on the location of train. Of course, when your bridge become very long, this vegetation become more complicated. All right, so it's depending on the where you put this train. So on in summary, you can see that just now what we have, the comparison between this thermal load, all right, is 5%. All right, so maximum compression compressive stress is 2.9, 5.3. Okay, quite close. So of course we are comparing this stage analysis, separate analysis. Stage analysis is what we call just now is complete analysis method, separate, and the UIC code. This is just to compare between these three different methods. All right. So else I think we can see that if 5% is just nice. If you ask me, 5.1 is allowed or not. So depends on engineering judgment. So all these kind of questions. So this is what we call the limit given by the code. So actually we use RSI analysis, not say a lot in our office, but of course we do it because of this criteria inside the what we call employer requirement. So why we want to perform analysis for this actual project in Malaysia? Because actually there's a two long span side by side, and separated by this two typical span. So we don't know whether this configuration will affect this rail or not. So that's why we have no choice. We need to do this analysis to determine that whether this configuration of these bridges will comply with this UIC RSI requirement. So if let's say it's typical span, normally we just ignore it as this UIC recommendation. You can ignore it. No need the real expansion joint. So for this case, I think section property is quite standard. This is a RC box girder. Of course, this is for typical span. For long span, because of very step, I didn't show it for each segment section property. This is a configuration of this one of the long span, 180 meter span. You know, mistaken here. This is about 60 or 65 long span. So actually this is a two long span. So it depends on the way you put this what we call the route of this train, right? So it depends on how many cars and so on. Of course, you can use this LM71 route motor. So to do it, let's say you're using for high-speed rail or for the standard kind of a railway bridge. So this another, of course, you have this thermal routing, blah, 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 together. This like a summary, where is it? Just now we just show it on this elevation, at least this on the 3D. All right, it's plus minus 20 degree throughout on the deck. All right, this is where you put this routing of this train. So you can see the temperature stresses to the entire structure. And braking and traction, it must depends on where you put these forces. Normally, we will put on this what we call long span there. And a vertical train route, this is one of the root case only. Actually, there's multiple root cases you need to consider. You can use moving road, but actually it's not so straightforward in terms of the support condition on the routed and unrouted condition. So this is a combine everything stresses for the whole analysis. Actually, it's a maximum and minimum. All right, it's an envelope. And then this is a summary. You can see that in terms of stresses, due to braking and traction, due to temperature and total blah 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 you have a vertical together with vertical load plus this braking and traction. So all is within allowable because the structure is using the track strap. All right, is this concrete track strap. So allowable is 72. If you're using the ballasted track, then this field value will be exceed the 72 limit. Deformation. On top of the real stress, actually, you also need to check the deformation, as I mentioned in the beginning of the slide. So there's a 4 mm criteria and 5 mm criteria, plus together is a rotation at the end. I think we have a problem on this rotation at the end. Others one is a relative movement as absolute horizontal displacement. I think it's well within the limit, but come to the two-end rotation, we have problem on the one of this model. All right, is so not put field, actually say not comply. Field is very sensitive. All right. On the rotation on top, actually there's one rotation on the requirement is another UIC code. You have to check this rotation also, not only the displacement at the end. You have to check this rotation, which the limit given is 0.0035 radian. I think all the model, we have done a lot of model actually for due to the live road. I think all is well within this limit, except the only one is quite close. All right, so I think everything is quite within the limit. So this is how we perform the ISI and checking all the results. So on the MIDAS Silver NS, it's a today time for the MIDAS. So actually, MIDAS Silver NS is quite new. Not only to you, to me, and to all the engineer in office also very new. So we are still learning. Of course, with this MIDAS NS plug-in tools, so it may make this analysis modeling and maybe extract the result become much faster. All right. So to come up with something is better than I show you some video. It's 2 minutes. How this RSI can be modeled in this using not only silver MIDAS, MIDAS silver, but with this MIDAS NS, how fast it can change the configuration of this modeling and how it can extract the result. With this wizard, everything now you can model. Normally, MIDAS silver wizard can do the straight bridge, but with this NS plugin, they can allow user to do the curve bridge by providing this radius and this spiral length. So you can do it in this NS plug-in method. So to me, it's a kind of a new technology. And of course, for the young engineer, maybe they can speed up the work. So that you can meet this boss requirement. So they say that we need this one to be done. Actually, it's not boss requirement. Actually, it's client requirement. So client always say, want it fast. Okay. So with this technology, you can do it very fast. If you go back to the conventional method, perhaps maybe you will take days or weeks. All right. With this new plug-in method. All right. So you can perform the modeling and change this. Oh, why? Oh, I think the screen has a problem in the screen. Cannot. Perhaps it's a blank, but I can see a lot of things here. So sorry. Now, all right. This sound didn't show anything. That's why I was surprised. You look at the screen also like nervous. So with these things, you can do it, model it, and change this alignment or everything with this plug-in tools. So it's quite fast. And then you can change this boundary condition to local axis quite fast. No need manually to input the node again and so on. Let's say you have this plug-in method. All right, I think there is a kind of a benefit of this using the MIDAS SQUARE NS. They call new experience. All right. So you can see that just from the straight bridge become a curve. It's so easy. So rather than you put back the nodes again. So you can change it very fast. With this one, you can change the local axis very fast. Let's say you have a soft structure, everything. So it's just a few button. All right, how to create, maybe the routing, and everything will be changed accordingly. Because normally for engineer, if we change the configuration of the bridge, definitely we have to redo the whole analysis again and modeling, right? So with this plugin, maybe you can do it. And of course, after the analysis done, you can extract the result to the Excel directly. So you can pick up the maximum force or stresses you want. So whatever you change in model, you just click back the same button, you can get back the updated result. So these are a few advantages we are using Tzyy and Alecs. So you can see straight away they give you the result, and you can update it when your model change. All right, so you no need to go back to the model and extract out the similar result. I think that's all. Is it finished already? All right. All right, so thank you very much for your kind attention.
Okay, thank you, Mr. Tzyy, for the impressive presentation. Please give him a round of applause again, please. Our next speaker is Mr. Alecs Chong from Orecon, who will talk about advanced analysis and where we are heading. Please welcome Mr. Chong to the stage, please.
Hello, everyone. Welcome to this MIDAS SQUARE event, and thanks for taking time to come over to this session. And also thanks, MIDAS, for inviting me to present my experience and share my projects. So this is the second presentation of today. And it's going to be a 40-minute presentation. So I hope to make it a bit more interesting, sharing a little bit more about my experience in analysis and how we apply it to real projects. So just a little bit about myself. My name is Alecs Chong. I'm the design director from Oricon, and I'm based in Hong Kong. I'm actually a Malaysian myself. I was born here and I grew up here, and moved around a little bit and worked in different countries. And then I moved to Hong Kong about 10 years ago, and I stayed there, and my wife, my family, they are all there. And I would like to talk a little bit about advanced analysis. To a bit more precise, is advanced analysis in structural engineering. How far have we come? What do we do now? And then where are we heading? So it's just, I will be sharing some of my experience with you. Hopefully you'll find it interesting. And also, in my view, what is really coming up in our industry. Okay, just the agenda of my presentation. I will talk about how far we've come. So just a little bit about this history of advanced analysis, or slash, I think, use it interchangeably, finite element method. And then I'll talk about the current practice, what we are doing, all of us that are doing right now on modeling and design. And then I will be presenting a few case studies that make use of advanced analysis. And then finally, I'll be talking about what is happening right now. And you might find it useful. And then finally, what's next, in my opinion. Hopefully that gives you a bit of food of thought for your work and what is coming up next. Okay, let's talk about how far we have traveled. So just a little bit about the finite element history. If you follow through, I think, the development of finite element method, it was developed in the 60s or 50s or 60s. And then there are some really famous people like Clough and Sienkiewicz. These are the guys, the big guys that actually come up with the theory of finite element method. It's actually a method that combines the theory that we as structural engineer really familiar with, direct stiffness method, with continuum mechanics. And that sort of lead us to that sort of diagram there. That was actually one of the very early finite element model that was presented by UC Berkeley. That's at that time, it was considered super sophisticated. So it's actually really cost mesh. Oops, just go back a little bit. It's cost mesh, but it's actually used to determine the structural behavior of a dam, a very important structure. And then just let's pan for 60 years now. After 60 years, we are doing things that looks like this. So what's really happening there is that I think that the brilliant people that came up with finite element method, that method is still around, and we are still using the same method. But actually, we're just pretty much applying to a different problem, make it more detailed, make it more complex, because we can afford to put more elements in. We can do it in three-dimensional. And it's just that I think this is just some of the examples of using, similar sort of problem, but we are actually developing very detailed model in what we do. Some people even sort of develop the valley of the dam, of the support, and modeling the rock joints. So what I want to point out is that I think all through the 60 years, we have been sort of chasing precise engineering. So we are trying to model things more precisely. And along the way, there are a lot of enhancements, like the development of different type of material models, non-linearity, and sort of. But we are still basing around the same theory. So let's move on. I think what actually made that happen? It's the enabling factors are that, if you heard about Moore's law, that is sort of like an observation in the beginning, and it's a prediction of the development of computing power. Gordon Moore, in 1965, he observed the development of semiconductor and transistors. He sort of predicted that computing power will grow exponentially. So that's the graph. I think you can see that it's actually a linear graph. It looks like a linear graph, but you actually look at the axis, it's actually logarithmic axis. So if you expand it linearly, you're going to get an exponential curve. So it's actually, I mean, he predicted it very correctly that I think in one of the microchips in 1970s, you have 1,000 transistors. And nowadays, in the microchips, you can get billions of transistors thanks to nanotechnology. And the other enabling factor is that why can we develop such a big model? It's because storage has become very affordable. It's a drop in price exponentially as well on the log scale. It's made possible for us to develop huge model and very detailed model. So what else is happening right now? So if you're following the news in the recent years closely, if you heard about Jensen Huang, NVIDIA, I think you know what is really happening. So he is the sort of like the big mind behind this development of GPU, graphics processing unit. So it's actually a big thing there that is driving the development of artificial intelligence. And if you just compare the traditional sort of CPU on the blue line there with GPU, I mean, in year 2022, you can see the difference of, I mean, GPU is 100 times faster than the CPU. So just think about the possibility if you can apply this in finite element analysis. That is actually one problem with it. It's because a lot of the finite element models or code were developed in the 60s using Fortran, and it's developed for the CPU architecture. So in order to make use of GPU, I mean, the software company needs to make some tweaks to their coding for the matrix factorization and solutions. So that gives you sort of like a flavor of what is happening around and what is happening in the past. And then let's move on to the next part of my presentation. So that gives you a bit of the context now. If you look back in what is happening for us nowadays, I'm from the bridges and civil structures team myself. So let's take the bridge as an example. So I mean, if you're a bridge engineer, you sort of know that. I think that is mainly sort of can be grouped into 4 types of bridge modeling method. So the first type is start from the simplest one to the most complex one. The first one is a spine beam modeling. It's really simple, very elegant. It doesn't mean that it's bad. Grillage modeling. If you have read the Hamley book, the Bible for bridge engineers, so you'll be familiar with this method for girder bridge design. And shell modeling, when you come to something that's quite complex, like an arch bridge, steel arch bridge with orthotropic deck, and then you might want to model the springing joint of the arch in more detail. You probably will be resorting to this sort of modeling to look at the fatigue stress and stuff. And finally, solid modeling. I mean, as bridge engineer, we don't normally come to this sort of level. Although I'm from the bridges team, I work very closely with the dams team and also the tunnel teams as well. They will look into the detailed sort of concrete cracking analysis. But for bridges, sometimes I think when you look at the anchorage, you would go into that sort of detail as well. But one thing I want to talk about spine beam modeling is that it's simple. It's a very low order sort of beam element, but we shouldn't look down on it. It's because of this simplicity and it's so elegant that it can be used very flexibly to model staging. For example, if you have a precast segmental bridge, that you can use it for balanced cantilever modeling and analysis, and then you can define the internal pre-stress in it. And we have actually used this to sort of design a bridge in Hong Kong in Chong Kwan O. This bridge has got one of the tightest curve of alignment in Hong Kong. Okay, so we looked at how we model a structure. I think there are different sort of level of details that you can model. But I think when we talk about advanced analysis, that is something that is sort of branching out from the base model that you've got. So it really depends on the different scenario of what you're dealing with. Let's start to look at, I think, the first one. So this is the sort of structural vibration. I think as civil engineer, structural engineer, I think we sometimes are actually, oh, this is not my problem. This is sort of mechanical. We just work out the frequency and that's done. But actually, a lot of time when we deal with bridges, especially pedestrian bridges, you might have pedestrian-induced vibration. You can assess vibration using this sort of method, structural vibration, and then if the problem still persists, you might need to come up with a damping solution. That is the sort of things that we would do. And then the next type of advanced analysis is long span and slender structure. This sort of structure is the type of flexible structure that you might need to consider geometry, linearity, to make sure you predict the large displacement. And the next type is the more detailed sort of ultimate behavior of structure, that you will start making use of the sophisticated material model to model the non-linearity in the material. Just a word of warning of using this. This is sort of, I think, I actually did my PhD in Sydney and doing a lot of programming in finite element, concrete cracking. And these are the sort of tools that is used to predict ultimate behavior. But as engineer, we have to make sure that we have the right factor of safety in place. So once you've got some sort of capacity worked out, you have to go back to the code to make sure that you have the right safety factor. And the next one is the stress analysis. We talked about the dams. The other one that I would say it's erection analysis. It's, if you heard of this, I think it might be for long span bridges. In the past, erection analysis is normally carried out on cable stay bridge, suspension bridges, because of the construction method will affect how you design your structure. But nowadays, because the structure is, I mean, if you go around the city center around here, around KLCC, you see lots of different structures of different shapes, long span structure. A lot of the contractor will be employing or engaging the consultant to come up with the construction methodology. And then we have to not just design the permanent structure, but also designing for the construction of the structure. And finally, the type of advanced analysis is to do with transient event simulation. I would call this sort of like the real-life simulation. What this means is that you're really putting a fourth dimension to your analysis, which is the time domain. So this is different to the time history analysis type, but it's actually simulating what is happening, combining material nonlinearity, contact between different parts of the structure. For example, car ramping into the barrier or explosion. So these sort of techniques is actually not just academic. It's actually applied in sort of engineering design. Especially, I think when we design a barrier, we will look into, occasionally we will look into ramping a truck into the barrier to see what happens. And there was one case, I think, that the requirement of design of a tunnel, we were required to look at blast, explosion. What happens to the tunnel? Would it collapse under the explosion? So that is something that we would do. Okay, the next part, I think we've looked through, I think, different sort of categories of advanced analysis. So I'm not going to go through each of them, but I've actually picked a number of interesting one. I think that might be related to what you're doing. So I'll be focusing on erection analysis. I'll make use of a couple of examples to illustrate that. The first one is the MIDAS Square Bridge in Hong Kong. This bridge was completed in the end of 2021. It's not a very complex bridge. It's an arch bridge, 80-meter long span. not super long, but what is interesting with this project is that the construction challenges that we face in the design. So I think construction challenges, if you sort of want to draw a line between the designer and the contractor, that you can say that I do the design and the contractor, please, Mr. Contractor, can you build it? But actually, I think because of the method of procurement nowadays, like design and build, we're actually getting into a role of actually designing for construction and making sure the structure is safe in the permanent stage. And at the same time, just a little note about this project is that we put in an award for Hong Kong Institution Engineer. We very luckily received the Grand Award, although it's such a small structure. So where it is, it's in Hong Kong. If you've been to Hong Kong, there are two sides of Hong Kong. That's the Hong Kong Island and the Kowloon side. And the bridge is located just right here at the sort of reclaimed headland over there. And that there is a point of entry into a tunnel that crosses to the other side. So that part of the land is called, it's right now called the West Kowloon Cultural District. And then it is just located next to the tallest building in Hong Kong. That's the ICC building, which is over 400 meters high. Right, zooming in to look at where the bridge is. So the ICC tower is somewhere around here. You can see the bottom of it. And that is a shopping mall called Elements Mall. And below that, there's an MTR station. So pretty much that's a transportation node there. And then that transportation node will take people into the station and then lead people into the new West Kowloon Cultural District. And where the bridge is actually here. So this is before the bridge was built. So the bridge will be built on 9 lanes of existing roads. So that is actually one of the biggest challenges that we've got. And on the other side, it's not the greenfield side. We have to actually open up the building facade and push the bridge in. Okay, before I go into more detail about the construction, I'll just give you some overview of how the bridge looks like. It's as I said, it's not a super long bridge. It's 80 meters, simply supported tied arch. So what you might not have noticed in this bridge is that there's a truss hiding inside just below the arch. So that's the Virendale truss there, and the bottom chord of the Virendale truss forms the tie for the arch. So pretty much it's actually, I would say, it's a hybrid structure. And our role as the contractor designer could not make any change to this arrangement of the structure that was actually developed in an earlier stage. But actually, our role is actually to make sure that it can be constructed safely within that sort of constrained environment that I just showed you. What else? I think there's some other features like a long canopy roof, about 30 meters long, and the sliding bearing is inside the building, the Elements Mall, and then it's supported on fixed bearing on these steel columns. Just putting things into context. So this is an overview of the site. So if you remember the Google map that I showed you, the ICC building or the Elements Mall sits over here, and that's a sliding bearing. And the bridge actually crosses over a number of existing roads, sitting on top of these big beams. These are new beams. These are pre-stressed beams. And the reason why we have this pre-stressed beam is that it's actually by another contract, it's not by us. It's just directly over a tunnel. So it's not making our life easy. Actually, there's another tunnel just right below that. Oops. Might need some assistance from technical. Yeah, it's back on here. Okay, sorry. Okay. Yeah, just over here. I think that's the AEL tunnel. That's in the operation. That tunnel is for the train that takes people to the airport. So it's a very important transportation that we can't damage. So that is some sort of surcharge limitation that we can put on top of this area here. And then over here, that's a big construction site when the bridge was designed. And I just want to draw your attention to this little diagram on the bottom left. That is the demarcation for the project. So pretty much, if you look at that, the length of the bridge is taking up the space where we can construct a bridge. So that is the biggest problem with the limited land in Hong Kong. As usual, as you know that, we all live in very small space, so we have to solve that. So just putting a little bit more information around it, I think that is a Google map picture taken just before the bridge was built. And you can see that's a huge site over here, a big ELS happening here, and that's going to be an artist square here, and then a big lyric theater building sitting around here. That's quite interesting that this building is supported on elastomeric sort of dampers because of the tunnels just run next to it, so they need to sort of damp out the vibration for that. So it's actually a site. It's an interesting thing. So the bridge actually is crossing over here, and the building is here. And what is not really helping is that Highways Department, the government department, told us we can't put any additional loading onto the existing flyover. So you can imagine that sort of challenge that we were facing, and how do we build it? We can't just stick build it, putting temporary support, and that makes life so easy. Okay, this is just another view. I think it's a point cloud scan that we did together with the contractor. Gammon is the contractor, Gammon Construction. They are very good with dealing with this sort of problem, and we work very closely together. So we look at the relation of the bridge together with what is happening around, and then also the limitation of the headroom and stuff like that. So we thought about different ways to build a bridge. So I think you have the problem right now. Maybe you can also think about what is the way that we can do to build this bridge. We thought about, can we lift the entire bridge in at once? No, that's not possible, because we don't even have a good space for the crane to sit on. And also we have the surcharge sort of limitation to not to be applying too high load to above the tunnel. Temporary works or temporary towers is not possible. Highways wouldn't approve that. And on the right side here, it's actually quite interesting. These are the two bridges that were built in Hong Kong at about the same time. And this is a really interesting way of building bridges in constrained site. And that one, it's I think very luckily they are actually building on top of buildings, that they can actually design the bridge to be built on the building and then get rotated in. But we don't have the luxury of being able to use the elements more as the support, because it's going to definitely overload the buildings. And what is happening here is that a similar sort of bridge, arch bridge, that was built over these big highways, and that was built, erected vertically, and then get lowered down. But again, we didn't have that luxury. We don't have space as well, so we can't rotate it up because it's going to crash into that building. So we went back to the drawing board and think about, I think, because the design of the bridge will really depends on what is happening with the construction. And that's what we came up with. So we thought about, okay, well, we can't build a bridge right over the flyover. Why don't we build it on one side, and then we launch it across? Wow, I think it's a great idea. Have we solved the problem? Actually, no. We still have another problem. Because the site is so small, we can't actually build the entire bridge on the temporary deck that we set up just next to it. The bridge itself is 80 meters long, and then the temporary deck is only 60. We are 20 meters short. So what do we do? So we can't, I mean, it's actually a very idealistic condition that I think we built the whole thing there, and then just push it across. Yep, okay, it's back here now. Okay, so we went back to the design, the drawing board again. What did we do? So we then came out with another idea, making use of the idea of launching. Sorry guys, let's give it a few seconds. Okay, yeah. So this is what we've done. So we did not launch the bridge just on one direction, but we came up with a two-directional launching method. That's a bit like we take inspiration from building something on a seesaw. So the seesaw is pretty much, I think you have the arms going out, and because of the lack of space, we have to build the bridge. Okay, let's maybe move on to look at this video here. This little video, I think you can see that that's 60 meters. You can build the bridge up to that point only, and then we start pushing the bridge backwards to make space for erect or assembling the rest of the bridge, and then the launching nodes then go across the road. So that was what we developed together with the contractor. That's a great idea, but how do we make it happen? Then we have to make use of advanced analysis. So this is where the sort of erection analysis came in to the whole picture. And as I said, I think erection analysis previously was sort of like applied more to suspension bridge, really long span bridges. But bridges like this, because of the constraint on site, we had to make use of a good method to predict how the bridge behaves when it was erected, just to make sure that I think that the bridge doesn't get overstressed when it was constructed. We build it safely. Not just safely, we have to build it to the right shape as well, because that's a contractual sort of shape. And one thing with this bridge is that the drainage of the bridge, actually it collects water, it goes to one direction. So we have to make sure that that's the right gradient that goes into the bridge as well. So if it keeps looping. So you can see that actually at different stages, how we model the launching is that we actually basically move the support. So the model stays at the same place. We keep moving the support incrementally to sort of mimic the movement of the bridge. And what else is important, I think, because it's not just a truss, but it's a sort of a hybrid truss and arch. So you can see that the arch is already there when it's launched across. But the problem is you don't want to overstress. It's a temporary stage of the structure. So something funny could happen. And having this model, we model it in MIDAS Civil, that actually helped a lot in giving us insights into the engineering design. So just share with you a little bit of what happens on site. I think taking the ideas, and realizing it on site, that's the first segment delivered to site, and then the assembly of the bridge over the 60-meter temporary support. And then you can see that sort of the sliding girder. I think that is the near finish sort of pictures. That one is when the bridge is launched backward. And that's a big cantilever there. It's about 24 meters. And that is, okay, that one is just before the launching across to the road. And then that's the final after launching. The launching actually took only one night. And the other night was pushing the bridge into the building and transferring the load to the permanent bearings. So just another picture of the bridge when it's at this biggest back cantilever of 24 meters. So a lot of people came to me and asked me, are you building the bridge the wrong way, because it's actually going the wrong direction? But so that's a little story that we could tell really about this bridge. And that is a picture taken just before the bridge was launched. And that's the completed bridge. Okay. Right, let's move on to the next case study. So I thought I'll give you another example. This is also on erection analysis, but this is, you might be interested to know about this structure. This is the West Kowloon high-speed rail station in Hong Kong. It's designed by MIDAS architect, and then it's got really interesting shape. It's a three-dimensionally curved shape. So I just want to give you an analogy how the structure behaves. We always say that the architect's dream is always the engineer's nightmare, and this is what we've got there. So just imagine that you've got a one-legged table, strange table, vertical leg, and you start putting books on top. As long as we make sure the book actually goes right into the center of that vertical leg, we can be sure that it's quite stable. Now, let's say we have a very strange issue that I think, okay, one of the legs, it's inclined somehow. If you stack books on top of it, you're going to get, that is not going to be stable. You get the P-delta effect. It's not a problem of just one incline table, but we've got 8 numbers of unstable incline table for the case of the West Kowloon Station. So what happens is that, adding to the complexity of the problem is you're adding different number of books at different legs. And then at the same time, you are asked to actually build a table on top of it to make sure that you cut the table into the right shape and put it in. So that is pretty much the challenge that we faced for this project. So how do we solve it? Similarly, we make use of the advanced sort of erection analysis. So where it is, probably I will skip through this. I think that you know where Hong Kong is. That's pretty much the bottommost point of the high-speed rail connected to the other cities in China. And that is the West Kowloon Station, I think, stripping all the external facades and everything off. You can see the roof is a 3-dimensional curved roof, and it's about 170 meters long, and then the width varies from 40 to 70 meters because it's shaped like a fan out, and the columns are actually 45 meters high, and they are really, really odd-looking columns that structural engineers don't like. So these are, some of them are 3 columns, some forms like 4 numbers of sort of X, so three-dimensional X that you've got. So it's a lot of issue when we want to build it, if you want to build it safely. A little bit more information about the roof. The roof itself, it weighs 10,000 tons. That includes the structural steel and the concrete that lays on top of the sort of the V-trusses, the 3 backbone V-trusses. And then the roof area is about the size of 2 football fields, so it's actually not small. And just this is a little bit about the structural system of the roof. So what it is that you have heard about that mega columns, the sort of the incline mega columns. And what is interesting is that apart from the V-trusses that is supporting things vertically, as well as providing the sort of the longitudinal stability, it's got the lateral stability system that looks like that. So the erection methodology has to be thought through based on how it's designed. And that is where the challenges begin. So just a little bit clarity in terms of how it looks like. It's not really a cross-section, but an elevation view. You can see that all the columns are actually sort of slanting to one side, and that's the south side of the roof. And you can imagine, I think, when you start building the roof with a slanted leg analogy, it's actually going to drift towards south. So you're pretty much building something on a floating platform, so to speak. And then what happens, I mean, you're going to induce, because of the rigidity of all these legs spreading apart, it's going to be putting push-pull into your foundation. There's a basement structure right below that. So it's a lot of things we have to work around to make sure that the structure is built safely. So this is one of the drift of the mega column is one of the challenges. And as you know, Hong Kong, it's in the typhoon area. You might have heard of Hong Kong having a Typhoon 10 sometime or Typhoon 8. Just to give you some information, when it gets to Typhoon 10, the wind gust speed can be up to 200 kilometers per hour. That's really, really, really huge, fast wind. So for doing the erection analysis, we don't just consider the vertical loading, but we have to consider the environmental loading, including typhoon. And the Hong Kong Buildings Code allows us to consider 70% of the wind load. But it's still a huge load, 70%. So it's a lot of challenges that I think, how do we make sure that the roof will be up there stable when it's partially constructed? Temperature is also one of the enemies. The roof of 170 meters long, and Dr. Tzyy also talked about temperature for RSI. That is going to induce the internal stresses. So this is the same case as well. So when I think the roof in its permanent condition, you can design for taking the internal stresses. But during it is erected and is supported by temporary structures, at some point it has to be laterally supported by the temporary towers. So the design of the temporary towers is sort of interrelated with how we want to build the structure. So all of this, actually, all this intricacy and complexity has to be solved during the sort of construction planning stage. And how do we build it? So we have gone through, I think it's the same thing. I think I'm quite sure you have similar sort of experience with contractors as well. If you work on a design and construct project, that they will come to you, how are we going to build this structure? So we have to consider all the factors that we just looked at just now to think about a way of building it safely. So we will make use of the stability system. So we start building the trusses like putting your arms out. So it's a bit like the balanced cantilever construction for bridges, but it's not like in the vertical sense, it's in the horizontal sense because it is to resist the typhoon loading during construction. So pretty much that's the principle, and that's the model set up to analyze the erection sequence. Okay, this is just another sort of like a capture from the analysis. I mean, having all the temporary works model as stiffness, vertical stiffness and horizontal stiffness. And that sort of gives us the idea of how it's going to deflect. And you can probably, I mean, you might have seen that, I think it's actually drifted to the south. I think if we didn't have this model, we would not be able to sort of predict how much incrementally it will move during construction. And also the benefit of actually doing such analysis is that it actually gives us insight to what is happening in the structure during construction. And also that you might have heard of something called locked-in stresses. Locked-in stresses is something that builds into your structure when you build it. But when you build something on stick build and on fully supported structure, you will not have any locked-in stresses. But when you're doing something that, I mean, complex structure like this, you will be having locked-in stresses, and then that is one thing we had to check to make sure that the locked-in stress does not go beyond the allowable locked-in stress. And this is just an example that I think showing the reaction on the temporary towers for the temporary towers design team. We picked up some critical points at different sort of construction stage. That there's a big load into the temporary tower. And so I think then that's an opportunity to really work together with the team to resolve problems such as this. Okay, just in summary, I think this sort of analysis will give you really insight into the behavior of the structures to make sure that the members will not be overstressed during construction. And then you can predict the incremental deflection of your structure, either to do the sort of survey, or you want to geometry control your structure and see whether you'll be able to achieve the final shapes. And what else? That allows you to come up with the cambering as well, because you want to build your structure to the right shape. Locked-in stress, we talked about that. And then also, I think the interaction with the supporting structure, the temporary supporting structures, and you need the design loads from the global sort of erection analysis to come up with that. And then also, that helps us to assess the basement structure or the foundation during construction that's not overstressed. Especially, I think when you have a mega project of this scale, you might be having a different contractor dealing with the basement structure. So that there will be some sort of connections or communication you have to make with them. Okay, that is the West Kowloon station after the construction is completed. That's actually it's a picture. I mean, it's a very recent picture, and that's the internal view of the West Kowloon station. It's a huge space. And you can, I mean, you can sort of, oops, go back to one slide. Okay, that's the sort of scale you're talking about. I think when you look at the model, it looks like quite small. Actually, you're having the people of that little size there. It's actually huge. It's a huge structure. I think a little movement of 50 mil will actually induce stresses of, I mean, it could actually overstress your structure. Right, just moving on to the next case study. All right, I think this is the sort of example that's quite close to myself because I spent a lot of time in my earlier years during research. I did programming of finite element modeling and predicting cracking of concrete. So this is the advanced analysis of nonlinear cracking of tunnel lining shear key. I'm not sure whether there's any tunnel engineer here, but actually, definitely, I think with MIDAS FEA, you will be able to do detailed analysis like this. So what it is, it's actually at the cross passage of the tunnel. We want to assess the behavior of the shear key. The shear key. Where the shear keys are, it's basically just okay. Just imagine. I think you have the tunnel, the cylinder of the tunnel. You unroll your the cylinder. This is what you get, I think, and the small pieces are the lining segments. So how they are connected together, especially around this area, is that because of the opening for the cross passage, you tend to get a lot of very big shear, and then this is where it comes from. We are asked to assess what's happening around the shear key and how it behaves and how we design for it. So the 3D sort of modeling method with nonlinear material, it's a very good way to go for this. A little bit more about the modeling. I think that these are the reinforcement within the segment using one of the functions in MIDAS FEA. We will be able to embed it in, and quite importantly that you pick the right sort of material model to use. So we've actually used the smear crack model in MIDAS. So what is really important with the smear crack model is that you need to define the right parameter in it. So the smear crack modeling assumes that a crack actually will be localized into a band of element. And you will need that's why you will need the right sort of fracture energy and the length scale. And the length scale that we're talking about here is actually the element size. And then when an element cracks, it will be localized into one row of element. And then this is just the basically the output that you get from the analysis. It looks nice. I think it looks correct. But I think what is really quite challenging with this is how you assess the result and whether they're making sense. So it's all about validation as well. I think Dr. Tzyy also mentioned about validation. It's very important. We don't treat it as a black box. If it is a powerful black box, it's a useless tool. So it can't be just a black box. So we have to validate the result. So you can see that it sort of predicts the shear cracking, the diagonal shear cracking, quite nicely here. That's the strain, plotting the principal strain and showing the localization. We also use the model to check the rebar stress, whether it's overstress, and also the reinforcing ring in the shear key. Okay, moving to the next part, which is the last part here. Okay, we have seen advanced analysis, what they are, and is that all? There are actually other things happening around. And we are actually doing it as well. I think in the bridges space, we are doing something called parametric design. So really making use of parametric modeling, the power of parametric modeling, combine it with analysis. So what it means by parametric modeling is that you don't model a structure by its dimensions. So you don't define the width and length with the exact number, but you define an A and B as variables. But basically, you're defining the feature of the structure. Let's say if you have a curved bridge, you define the radius as R, and then the length A and B and connection and so on. So this is the sort of like the principle behind parametric modeling. And why parametric modeling? It's because parametric modeling will allow us to set up the workflow, the entire workflow, normally in the visual scripting environment. For example, if you heard of Grasshopper or Dynamos, these are the things that people are using nowadays. People will tend to use more Grasshopper because it's got more sort of library. And the beauty of this is once you have the parametric model set up, you have the control variable that you can control your analysis, and then you'll be able to use the same sort of parameters to control your, to input your documentation. It seems like it's some ideas, but it's actually happening. I think in our team, we are actually using the same tool, actually designing an extra dots bridge in one in Hong Kong and also one in New Zealand. So just give you an example. This is an extra dots bridge. In the background, these are the scripting. So this is how it looks like in Grasshopper. You'll be defining some parameters and interconnecting it with each other to form the relationship that gives you the entire workflow. What it means is that is actually sort of the workflow and that is set up with the scripting. So you first define the geometry as features, and then you define the parameters in the scripting environment, and then you bring everything into MIDAS. For example, MIDAS. I mean, at this point, I think I have to say that we have been doing it using the MCT files because that's the text format that we can interact with. We are really looking forward to the new version of MIDAS Civil NX, which has got the API that will allow us to interact with Grasshopper more seamlessly. So with that, you set up the workflow. So what happens is that once you have the workflow, initially you might get a straight bridge. And then just think about, I think, with the right sort of changes that you make, put a few fingers there, is that I think I would just want you to visualize how you can change it. You can actually change the shape of the structure quite quickly with that sort of interaction. So it's basically setting up the entire workflow, and it's particularly useful for optioneering in the beginning of a project. And so it really depends on what stage you are in your project. If you are actually, for example, the RT square bridge, you already have the geometry all fixed, so it's really not worth going into this path. But for bridges like this with internal pre-stressing tendons or precessing tendons, you can actually make use of this workflow to control how you profile your tendons as well, which is really, really useful. This is another project that we made use of parametric design. This is the northern pathway in New Zealand. Okay, the final part of this, what's next? We've seen a lot of things happening. I think there's a lot of tools. I think with the increasing speed of computer, I think we have superpower. But what's next? I think, just a little bit of disclaimer. What I'm going to show you is a video created by my colleagues in Melbourne. It's nothing to do with structural engineering, not design, not engineering design, I would say. But actually, I would just like to give you sort of some inspiration of what you can do with all the tools that we have got. I just play this video. Effectively, this is a very interactive tool called Comfy UI. It's actually doing some sort of modeling similar to Grasshopper that you've seen just now, but it's actually using some instruction below here to instruct a program to actually create some visualization up there. It's actually making use of AI, artificial intelligence. So you can see that it's so powerful that I think you don't just tell it with words, but you're actually developing some sort of three-dimensional object in 3D space that the tool actually picks up and creates something quite creative over up there. This is not for structural engineering yet. I think this tool is for my colleagues who works in the sort of like the visualization department. And I just want to open up that sort of thoughts for you. It's really food for thoughts. So what we can do next, and we all, I think Jensen Huang is everywhere. We know that. I think we can't get away from him. And Sam Altman with his ChatGPT. So could it be AI? How do we incorporate AI in our design? I think parametric design is a good way to start because everything is in parametric form. And AI, I'm not saying that AI is going to replace physical analysis engine like MIDAS. MIDAS, it's actually still very important, or other analysis software is still important to get the right engineering solution. But AI would be able to get in there to help with the process of coming out with the best solution. For example, if you're talking about designing pre-stressing tendons, would you be able to get AI to help you provide a better solution? Okay, I'll leave it there for you. I think it's really some food for thought. We don't have the answer, but we have to work through it as engineer. What's coming up next for us? Okay, thank you very much. Hope you find it useful and interesting. Thank you.
Well, please give him a round of a big applause, please. Thank you, Mr. Chong, for the insightful presentations. Now we have another exciting presentation coming up next, so please stay seated. Remember, if there is someone who finished STEM tour at the event zone but didn't receive the lucky draw ticket, please take one ticket at the event zone. That is for the lucky draw session in the afternoon. Okay, so let me introduce the third speaker. Our third speaker is Mr. Abinales, former president of the Association of Structural Engineers of the Philippines, so-called ASEP, and a veteran in civil and structural engineering for nearly 40 years. He will discuss upgrading and strengthening a 990 meters long iconic arch bridge in the Philippines. Please welcome Mr. Abinales to the stage.
Good morning, everyone. Yeah, thank you, Hero, for that introduction. So I would be presenting actually a project application in our country, Philippines. It is the project is located somewhere in the northern part of the Philippines. Of course, we have regions, no? Region 1, Region 2, and so on. But this project is actually located in Region 2. Next, okay. So the project is actually, the bridge is already existing, and for some quote-unquote problems with regards to the opening, no, for this project, for this bridge to be used, the government has to make an upgrade and strengthen this bridge. It is actually called iconic in Region 2, because it is about 990 meters long. Well, the government tagged it as to upgrade this so that to ensure safe and reliable infrastructure in our country. So the contents of my presentation would be as follows. Let me present to you the bridge project information, then present to you the design parameters, the codes and standards that we use in our country, and then do the modeling using the MIDAS Civil, and then the analysis relating to the design of strengthening, and the concluding remarks. Now, for the project of information, the bridge is already there, and this is the bridge. It is crossing a very wide river in Region 2. It's very wide. That's why this bridge will have to be part of the bypass road in that region. Then there are actually other bridges which are already existing there. The total length of the bridge is about 1.2 kilometers. And there are two segments of this bridge. We have the main arch bridge, which you see on the photo, and the approach bridge, in which we use the pre-stressed concrete girder. So you have here the details of the bridge. We have the bridge on the approach, the northern side, extension A, which is about 240 meters long, 8 spans of 30 meters length, using pre-stressed concrete girder. So there you are. And this is the main bridge. You have a total span of 12, each 7, I would say 60 meters, no? So the total length is about 720. And you have this approach bridge on the other side, which is extension B, a single span of 30 meters, pre-stressed concrete girder. So this is the total, the overall view of the bridge. So this is the extension A. This is the profile of the bridge using type 4B, pre-stressed concrete girder. And this is the typical section of that bridge. This is for the main arch bridge, a total of 12 span, each at 60 meters. And this is the typical deck slab. Actually, the superstructure is made of structural steel. And this is the arch bridge. Now, originally, the intent, no? The original designer is to come up this bridge using built-up sections, a lattice, 4 angles like a box, and then all connected with the lacing members. So this is the typical section of that arch. And these are all connected to a coping beam, which you can see at the ends of the span. Now, this is the sections and elevations of that main arch bridge. Now, for the extension B, you have the 30-meter single-span pre-stressed concrete girder. So this is similar to the other extension approach bridge. They have this is the typical plan and elevation and the typical cross-sections. Now, for the bridge design parameters, I will not go into the detail of what are the loads that we considered here because basically I think in the presentation of Dr. Te, he has already somehow give you an idea on what are the loads. But although we have a different code that we use in our country. So for the material specifications used, for the bridge, for the reinforced concrete, we have the concrete strength of 24 megapascal. For the deck slab, for the pre-stressed concrete, for the concrete arch rather, we have 28 megapascal. And for the reinforcement of 420 megapascal. For the pre-stressed concrete, we used 35 megapascal with the yield strength of the pre-stressing bars 1860 megapascal. And then for the structural steel, which is that of the superstructure, we have 345 megapascal for all the elements. And for the bolts and fasteners and nuts, we are conforming to this ASTM 8325. For the codes and references in our country, we have the DPWH, which stands for the Department of Public Works and Highways. We have these design guidelines, criteria, and standards, what we call this DGCS. There are actually 5 volumes of this document, in which volume 5 is all about bridge design. And that was published in 2015. And coupled with this DGCS, we have this, the bridge seismic design specifications, or the BSDS, in which we use this document for the seismic design of all the bridges in the Philippines. And we already had the second edition, which was published in 2019. And all of the specifications, DGCS and that of the BSDS, all of these are adapted from the ASTO LRF bridge design specifications published in 2012. I guess we are the only country in the Southeast Asia wherein our codes is patterned from the American codes. For the bridge modeling, we started with by the way, when we were engaged in this project, this was during the height of the pandemic in March 2020. So, well, definitely because of the lockdown, we have to bring all our works at our homes so that we can still continue with our work. Because this is a critical project during that time, so we did the modeling in my home, in my personal home. So I have to tag along one of my engineers, and I have to tell him that he should stay in our place so that we can work on this project. But I think that was the start wherein the work from home have been very popular during the pandemic. So we start with the modeling of the arch. And the good thing about the software, in which is MIDAS Civil, we have this section wizard feature of the software, wherein somehow we could make, no, or we could do ease in modeling. Then, of course, the arch is integrated to the coping beam. And of course, this is the single line modeling of that bridge arch. Then complete with the piers. The coping beam is supported on 2 column piers, and then the column piers down to the board pile. Now, the design here is you have the pile cap at the base, and then these pile cap are supported on large diameter board piles. So to complete the modeling, we, as I've mentioned, the longitudinal members are made of structural steel elements. Then for that arch, wherein you have to provide some struts at the top, so we have the diagonal and the horizontal struts. And then for the transverse elements, and then the cross bracing at the end of the end bay of each span, then down to the board pile. So it's something that we have to consider the board pile as part of the modeling, and of course to consider the site, or rather the soil structure interaction. So there you are. And then this is, well, basically for the arch being connected and integrated with the coping beam down to the 2 column pier down to the board pile. That portion wherein you have to, a very large coping beam section, and then you have these arch connected to that. So I think one feature of the program is to define the general link in the modeling. So until we complete one span, and then apply it to all other spans. And then completing the entire stretch of the bridge, including the approach and that of the other end approach. So I would say that we have this advantage, no, using the MIDAS Civil, because I guess the software is versatile, no, and the modeling made was quite easy despite a very complex configuration. And you could simulate the model like very close to what is the real thing. So in our work here, no, since this bridge is already existing, we have to do some upgrading. Why do we have to do the upgrading or the strengthening? I guess that this was already mentioned by Doc Alecs, that erection, no? I would say the erection analysis. During the construction of this bridge, the bridge because of the, how does it work in our country, that they have to do some phasing of the project depending on the availability of the funds. So when this bridge was being constructed, they have to face it in a way that you will note here. The first phase of the project is this portion here. Then for some reason, depending on the availability of the funds, they have to consider this as phase 2. But during construction, because that they have to stop at that point, the pier moved about 178 millimeters to the right. So that was a big problem then. That's why in our evaluation of this bridge, we have to do some, of course, inducing this as 178 displacement as part of the analysis. And then, of course, trying to analyze it in a way that you have that deformation. But luckily, quote unquote, that when they resumed the construction for the other segment of the bridge, somehow they were able to put it back, to that position. But still, you have the displacement, quite minimal already. Second thing, when this bridge was designed, sometime in 2014, the DGCS was not published yet. But this was already constructed right after the publication of the DGCS, which was published in 2015. So in our previous design of the bridges in our country, we were using this LFD design approach, based on ASTO, and we have this NSCP, which is the National Structural Code of the Philippines, Volume 2, in 1997 published, which is quite, as far as the code specifications are concerned, it's quite different from the AASTO in 2012 LRFD edition. So in that case, when AASTO was published in 2012, adopted by our government as part of the 2015 DGCS, so we have to redesign, or rather re-evaluate this bridge using the LRFD. And of course, because of the change, because we have to make sure that this bridge would be safe and reliable, so we have to do the renovation. And what happened then is we have to do some upgrading and strengthening. So for the exterior stringers, in the longitudinal direction, we have to, as I have mentioned a while ago, the superstructure is made of structural steel. So we have the original section, which is a built-up section like a wide flange or a plate girder, and then we have to provide additional plates to make it as a box. So now, actually, the retrofitting or the upgrading is ongoing, and this is the photo that you are seeing here are actually the actual works being done at the site. For the interior stringers, we also do the same thing. We have to make them as a box. For the cross beams, in the transverse direction, the same thing that we have to make it as a box. So you see, these are the photos of the ongoing works. For the bottom longitudinal direction, this one here, this horizontal cord is actually connected to the arch. And that is where the big problem actually happened during the construction. Because the connection here originally, this cord here connected to that arch here, it's all about the issue or the problem about the connection details. And the same thing that this bottom here, we'll have to make it as a box. Okay, this is for the pier. The original diameter of the pier is actually about 1.4, some other are 1.2. But there are, very long piers. So 1.4, if you try to look at the entire bridge, from afar, you will note that even if you are not an engineer, you will think that you have a very massive, bridge, wherein when you look at the pier or the columns, seems to be small, like I would say a cow. We have a big body, then you have a very slender legs. So we have to do some, enlargement. No? In this case, since we are limited to this space, so we have to using steel jacketing. So this is how we did, no? And then of course bolted down to the pier cap, or rather the pile cap. So this is the section of that enlargement of the pier columns. Then we have to replace the cross bracings, especially at the end segments of the typical span. So now this is the new section, because originally it was just a plain round bar. Now this is the one which I'm telling you about, the connection of the horizontal cord to that of the arch. Maybe this could be something like related to some construction methodology, wherein the connection details was implemented in a way that the original intent of the designer is to make at a moment connection. But what was executed at the site is a shear connection. So the bolts were sheared off. So some of the, because of the movement, so some of these bolts were somehow sheared. So we have to make it a moment connection based on the original intent of the designer. So in this case, we have to do some, a massive connection shear to put it back to the original design intent. So this is now the actual work for the connection rectification. Other recommendations for the strengthening, we did the CFRP, or the carbon fiber wrap, reinforced polymer wrapping of the end segments of the bridge arch. And then we also did the crack repair of the deck slab, because there were some portion of the deck slab, for some reason, that there were a lot of cracking, so we have to do intensive epoxy grout injection. And then a provision of the steel brackets to support the cantilever sidewalk slab. So as you can see here, maybe you could ask me why. So why we have to do that? Because in the detail, in the drawings, what do you call this? The fabrication drawings, when we saw the details, they are supposed to be cantilever slab, but all the reinforcement were placed at the bottom portion of the slab. That's why, cantilever, so the reinforcement should be placed at the top. So sort of a construction lapses, no? And the reinforcing diagonals and horizontal struts were all, well, basically we recommended to replace them, but for safety issues about doing it, So we have to simply reinforce the existing diagonal strat as well as the horizontal strats. Then this is now, of course, after the assuming that everything would be executed as retrofitted. So this is the first mode of vibration in the longitudinal direction, and this is the first mode of vibration in the transverse direction. You know, this bridge is, I would say, according to the local government in that region, would serve as an iconic bridge. And a lot of bloggers have been visiting this bridge because they wonder that in 2020, this bridge is supposed to be operating already, I mean, used by the public, but because of some problems, so we have to do some upgrading. And, you know, because bloggers in the country, are very, very aggressive. So this is one of the videos which I took from the YouTube. So what you can see here at the, a detour road, so that people from the other side to the other side would be able to cross that river. Of course, pardon for the vloggers using Tagalog, because he is a vlogger, a Filipino vlogger in our country.
Ng Santa Maria at Cabagan dito sa probinsya ng Isabela. Sa disenyo nitong nahulog sa mga tulay na makikita sa
people in the area would say this as a joke, that this is the most expensive pedestrian bridge in the world, because at this point in time, only people can use this bridge just to cross from one point to the other point. Although they allowed the motorcycles to pass this bridge, but still since the work is ongoing, so they have to close it for a while. But soon, this bridge will be open. And actually, as we are projecting that this bridge will be open sometime in, hopefully, September this year. So as a concluding remarks, with the emergence of this sophisticated and powerful software computing tools like MIDAS Civil, modeling of bridges, quote unquote, is no longer complicated. Oops, wala. So, okay. And any form, sorry. Oops, we're going back. Yeah. Okay, sorry. Okay. Anyway, any form of configuration, I would say that with the software, with the powerful software that you have at hand, then quote unquote, the life of a structural or bridge engineer would be somehow easy. But still, we are the engineers, so we still have the critical mind to to discern whether what you are getting from the analysis, as calculated or computed by the software, would still be your judgment. So you still have your mind, wherein these software are just tools for us to be utilized. So I'm showing here of course, our government, DPWH, the publications, the references which I used, as well as the AASTO, and that of the MIDAS Civil software, and my engineers who work with me in working on this project. So with that, thank you very much and have a good day.
Okay, thank you, Engineer Abinales, for the excellent presentation. Please welcome them for the Q&A and discussion session, please. Okay, here we have selected questions gathered in advance. In total, 10 questions we have. And after the selected questions, you can also put your hands on and you can ask some questions to the speakers. So for the first, can you flip the, yeah. Let me read the questions. It seems this question for Mr. Tzyy. How do the interactions between the rail track and the supporting structure affect the overall stability and performance of the railway system? And what measures can be taken to mitigate any adverse effects? Can you answer this, Mr. Tzyy?
All right. Actually, this interaction between the rail track and the bridge is very important criteria for this railway bridge. So, in order to enhance the stability and performance of the railway system, of course, as I mentioned in my presentation, long rail definitely is a must go, because due to the comfort and this for the ridership, and of course this maintenance for the long-term maintenance. All right. So that's why this RSI is very important to give how to get or ensure that the rail is stable not only on the stress but also the deformation, which will cause this rail break. So, and of course, this RSI, why this RSI it come to picture. Of course, on top of this RSI, actually there's a different type of this stiffness or grip to allow this rail can be expand, all right, more freely. There's a keyword that we need to take into account. So a lot of RSI done by this engineer actually is just purely on the additional stress induced to this rail, but the deformation, especially on the embankment, we have to work closely with the geotechnical, especially on the interface between the embankment and the structure. That's always a problematic area. So we hope that this RSI will give the insight, this kind of information, not only for structure, but also for this civil geotechnical engineer to look into it, because it will affect this rail.
Yeah, so you keep highlighting on the importance of the RSI, right? Okay. For the next question to Mr. Tzyy, what are the primary factors influencing RSI, and how do these factors impact the structural integrity and performance of both the railway track and the supporting structure?
All right, as I shared together with all of you this morning, I list down some of the factors, especially the span length, all right, and this support configuration, like the fixed end, free end support. This definitely will influence impact to the rail. So I hope that my presentation this morning gives you some insight information for you, so that when you plan the bridge for the railway bridge particularly, so don't like thinking it's a highway bridges. I hope that the factor I already presented this morning will give you overall idea on this importance of this span, support condition, and even the stiffness of the substructure and foundation also.
Can you give some samples of the supporting structure again, please?
Yeah, I mean like stiffness of this substructure foundation. As I say, you cannot keep too slender, or you also cannot really keep very stiff. All right, it must depends on the need. Of course, to me, for the railway structure, the important factor is a span length, right? So that normally the railway structure will come out with the configuration is a simply supported rather than continuously a long span structure. So I think this is a key factor for us to consider as a railway bridges.
Understood. Thanks for your answers. Can we move on to the next question, please? Okay. Why was, this is question for Mr. Chong. Why was MIDAS Square Bridge designed with the combined arch and truss system?
Thank you, Hero. It's actually quite an interesting question. I think the bridge, as I mentioned, it's made of a tied arch and together with a truss, which is a very new truss. That I would say that was actually developed in an earlier stage of the design by the reference designer. And pretty much when we get into the project, we actually have to take over that sort of design to develop the detailed design. And what is really interesting with that is we actually made use of the hybrid structural system of the Virindale Truss for the launching. I think I would say the launching wouldn't have been possible without the truss in it. So that is one of the benefits, and then actually sort of going deeper into why it's a hybrid structure. It was actually designed with a truss to mitigate vibration. In Hong Kong, actually, the requirement for pedestrian vibration is actually quite stringent. Then we have to meet the sort of acceleration requirement, and the function of the truss itself is to sort of provide a bit more stiffness to the arch system, and then to work together so that it becomes a very, very stiff structure. And especially if you look at the bridge itself, 80 meter long, the width of it that I haven't actually mentioned is about 8 meters. So it actually we have to accommodate a big crowd during the sort of the event that is held in the West Kowloon Cultural District. So that is really to account for all that sort of big crowd movement there. Yeah.
Okay, thanks for your answer. Can I say that? Oh, yeah. It seems like a practical question here we have. For the shear key analysis, how did you model the reinforcement in the lining segment?
Yeah, okay. Right, normally when we do modeling of structure, we just go on to the sort of linear type of analysis. And because I think this analysis, we intend to carry out non-linear assessment of how it behaves in terms of the lining segments and the shear key. We had to put in the reinforcement. And how we did the reinforcement modeling is that I think within MIDAS, that's a few different ways to do it. I think one way is that you can actually put the beam elements that's aligning with the mesh configurations. That means actually you put in the beam to stitch into the nodes of your solid. But the way that I did with the shear key analysis is that we actually used the embedded reinforcement functionality, which is very convenient that you can define your reinforcement not aligning with the mesh configuration in your solid. So that gives us a lot more flexibility in terms of meshing and stuff like that. But just one point to note is that I think you for some circumstances you might want to model the bond slip. Then probably you have to actually go on with the sort of alignment sort of beam modeling into the solid elements. Yeah. So I think in short, I think we actually use the embedded modeling method for the reinforcement.
Okay. This is for Mr. Adam. Actually, we can see easily newly constructed high-rise buildings and the bridges in Malaysia. And so I think this is the question from these circumstances. Based on your presentation, the existing bridge is newly constructed. Why is there a need to upgrade and retrofit for the newly constructed bridges?
Okay, thank you for that question, Hiro. Well, basically, actually, I already mentioned in my presentation why this bridge is to be upgraded and at the same time retrofit, considering that this bridge is just newly constructed. Yeah, for reasons number one, now since there is this induced displacement of the entire bridge, in particular the main arch bridge. So we have to do the re-evaluation, and then with that induced displacement, then we see the effect on the overall stability of the bridge. Second, since this bridge was originally designed using an old quote-unquote code which we used before, and the time that this bridge was constructed, it is the new code is already published, and the government would like to ensure that this bridge would still be reliable and safe, considering the new code specifications as published by the government. So we have to do the re-evaluation using that premise, and then ergo that we have to do some upgrading and retrofitting.
Okay, so the retrofitting is significant factors for
That is correct,
for
and
all the
especially
structures.
that this bridge is crossing a very wide river, and the government, in particular the local government, no, in Region 2 would like to make sure that this bridge would be able to test, the effects of the loads, especially that our country is in a high seismic risk region, and the earthquake is, in the past, especially in the Region 1 and Region 2, which is the northern part of the Philippines, there are a lot of series of earthquakes that have been happening since actually 2022, last year, there was this major earthquake that struck northern Luzon. So we have to check. In fact, that's the reason why the more that we have to do some retrofitting, because when that earthquake struck in July 27, 2022, there are a lot of, some visible cracks that were observed in this bridge. That's why we have to do this strengthening and retrofitting.
Okay, I'm not sure what this, but this can be a question for all of you. Is there any regulations from the government for the companies should do the safety inspection, something like that, for the regarding the retrofitting or something? Do we have?
Yeah, in our country, yes. For buildings, we have this mandatory structural assessment of the existing buildings, especially those old buildings and those buildings which are more than 15 years, 15. Much more that you have all these existing old buildings which is more than 50 years. So before these buildings would be given, some sort of occupancy permitted, especially if this building is being used for commercial use, then it is a requirement that these buildings would have to be assessed. Same thing with the bridges in our country. In Metro Manila, there is what we call as the big one, which the government, our FIVOX, which is the Philippine Institute of Volcanology and Seismology, has been telling us that the big one may happen anytime in our lifetime, that all the existing facilities, in particular the bridges in Metro Manila, are actually undergoing this rehabilitation.
Thanks for your answer. Any answers from others? No?
Maybe I just add to that. I think for existing structure, for example, infrastructures, bridges, I think the government normally they will have a team of sort of maintenance team that they will sort of maintain the structure to make sure that it's in service as intended. So actually, they will be carrying out periodic inspection. I think the consultant will sort of come in when they actually identify problem. They will probably then tender it out to look for solutions on how to solve that problem. Yeah.
I believe Malaysia also practice the same. All the authority or the project owner, they do practice this what we call the inspection requirement. Like for example, Malaysia Highway Authority, even the Pelaksana, they do have this kind of schedule, kind of inspection, maintenance, and assessment practice to safeguard this bridge.
Yeah, it seems quite similar for the other countries as well. Yeah, okay. So let's move on to the next questions. This is for Mr. Abinales. What could be another alternative retrofitting scheme for the piers considering the same situation of the existing bridge, especially in the transverse direction?
Okay. Yeah. In my presentation, I actually presented one scheme, which is the use of steel jacketing. Actually, we did some other schemes. We actually considered even providing this lateral bracing, like for example, in the use of dampers or, basically I think dampers. But because of the budget restraints, so we have to think of another scheme. Now, I haven't shown it in my presentation a while ago that in one of there are two set of piers wherein we did not only consider steel jacketing, but we also make it since you have a two column, and then we have to provide additional web wall. So there are two locations of these piers wherein we have to provide web wall. So it's actually in my photo. There are reinforcement already being set there and placed for the web wall. So that's one of the retrofitting schemes we considered.
Okay, thanks for your answer, Mr. Abinales. The question number 7 is for Mr. Tzyy again. How can RSI be accurately modeled and analyzed to predict potential issues such as track misalignment, differential settlement, and excessive stresses on a supporting structure?
All right, as I say in my presentation, validation of this analysis modeling is very important. That's why somehow or another, a lot of engineers actually ignore it, or maybe they are not aware of this kind of requirement to validate their analysis model is accurate enough or not. So for this instance, of course, this is very important, as I mentioned and this morning, and share with all together. So perhaps next time you come across RSI, before you straight away to jump into the project and modeling, perhaps validation is important. Of course, it's another way for the senior engineer to validate the result, because mostly all the analysis will be done by this junior engineer on the modeling and analysis. So this is another kind of proof that validation has been done. Of course, to predict potential issues that track misalignment, differential settlement, and excessive stress on the supporting structure, this is very much depends on your project and so on. Right? To predict this track misalignment and real break, perhaps maybe we had to discuss or communicate with this real supplier or expert, because all this thing is what we show in this morning actually is just a requirement in the code, right? So in actual fact, the behavior of this rail and together with this what we call the system on the rail, it must depends on this perpetuation system from the supplier. So of course, to predict it using the RSI, I think is quite impossible, to be honest. Of course, like differential settlement, all these excessive stress on the supporting structure, as I say, if we put the expansion joint at this rail, then the rail temperature effect will affect this structure. So it becomes a two-way. So we have to be very careful on this kind of requirement. Of course, differential settlement, and this morning I didn't mention it. Of course, differential settlement on the bridge structure will cause this internal stress, induce the internal stress to the rail. But somehow or other, perhaps if you think this is a sensitive area, but of course you don't do take into account this design requirement, like plus minus 12 this kind of things. We have to be more realistic, like take into account because the settlement or defense settlement mostly is due to the state load itself, because the whole bridges state load and superinput state load may already take up 70% or more. So your live load actually is maybe 20 to 30%. So you have to calculate the real, perhaps it's a more accurate kind of settlement due to the live load only. Then you take into account on this RSI. Even though it's not mentioned in the code, somehow or other is you encounter very soft soil area. Maybe you need to take into account, all right? So.
Okay, so it means like sensitive areas needs different requirements, different kind of requirements.
Yeah, I mean, it's on top of the code. If you encounter something, it may affect the real or your structure. Perhaps the engineer need to make a good judgment on it.
Okay, it seems like it's quite a bit simple question, but significant. Is the RSI analysis required to be carried out by viaduct design structure engineer?
Yes, of course. The RSI analysis actually, by right, is not required to be carried out by viaduct designer structure engineer. So along the way, I can say that now the client is very demanding. So before they appoint or engage with this track work contractor or the designer, they may want to know what is this result or the effect of the structure to the rail. In those days, I think viaduct structure designer seldom. I cannot say never, but it's seldom carry out this RSI analysis. Perhaps maybe due to the modern software now, so it's so easy to carry out. So now the client is so smart, ask you to include all these additional service from the consultant. So perhaps I think it's not mandatory for this viaduct design engineer to do the RSI. Yeah.
Okay, thanks for the answers.
Maybe just sort of supplement on that. I think as a designer, actually, we have to actually carry out due diligence to make sure that I think what we design is going to be servicing the future operation of the structure as well as the structural life. So I think we don't know what we don't know, but actually now we know that it's an important sort of interaction with the structure. I think we should carry it out to satisfy that the design is good. Yeah.
But I want to add on is this one is still purely this track work consultant responsibility, not the viaduct structure design responsibility on the rail. Yeah.
Okay, please move on to the next question. Yeah. Okay. It seems quite similar with the question before. To Mr. Abinales, have you considered other analysis procedure for the design of retrofitting the existing bridge?
Yeah, actually we did, although it was not part of the terms of references provided to us when we work on the project. But for our, sort of a level of confidence, we are actually doing other alternative procedures in terms of analysis. In fact, we even considered the pushover analysis nonlinear static, so that we will be able to, more or less see how the entire bridge will behave when acted upon by these expected loadings. Although, of course, in the terms of reference, it was only mentioned about, this what was prescribed in the code, and that was multi-mode analysis as a requirement of the government. And again, as I have mentioned, that we also consider other analysis procedures.
Okay. Can we move on? Yeah. I believe this, most of us are curious about this question. because your presentation about the MIDAS SQUARE bridge was impressive. What was the launching mechanism of MIDAS SQUARE bridge?
Thanks for the question. Actually, a lot of people ask me about this. I mean, I would say it's actually it's really a variable experience for myself as well, working together with a contractor that is willing to look into some different way to construct a bridge. At the same time, we are working with the specialist contractor to sort of realize the launching of the bridge. So VSL was the contractor. They were involved in sort of coming out with the temporary works and the launching mechanism. So how it was done is that it was actually launched supporting the bridge at 4 points. So 2 points front and back at one side of the bottom chord, and then the other side with 2 points. So basically, I think each time when it is launched, there will be sort of, if you think about, there are 2 pairs of launching pad. So when we launch to the back, the front one will become just a roller support. And then the other side is going to be launched by a horizontal jack. At the same time, there is a vertical jack as well, because you can only launch the bridge bit by bit, considering the stroke of the jack. So it's sort of like a cyclical way of you're actually pushing the bridge with a horizontal jack when that sort of support is supporting the bottom chord. And once that stroke is done, then you have to use the other vertical jack to jack it up again, so that the horizontal jack will actually be able to sort of reset its position. And then you sort of transfer the load again and push it again. So basically, that is sort of the cyclical mechanism that was involved in the launching. Similarly, when it goes to the front launching, then the jack actually behaves similarly, but actually moving sort of in a different direction. Yeah. So basically, I think there are only 4 points supporting, making sure that it's sort of simply supported. We are not inducing additional unwanted stresses into the structure when it was launched.
Thanks for your answer.
Thank you.
I think we're all done with the questions that we collected in advance. I think we can get 1 or 2 questions more on site, if the time allows. Can we? All right, good. Okay, so if you have some questions more, you can just put your hands on. Then we can just turn over the microphone. Okay, please, here.
Sorry, basically I got 2 questions on. Maybe before I forgot, the first question I would direct it to Dr. Chong, is it?
Yes, yes.
As what you have mentioned just now in your this mechanism, so is those jacks, the horizontal jack that we are talking about, are they synchronized? And then also, where are they sitting when they slide? So that's the first question. My second question is directed to Mr. Tzyy. Since the RSI analysis is very interesting to me, so my question is there any tolerance settlements for, say, comfort riding at a speed of, say, 180 kilometers per hour, especially at embankment area? Thank you. These are my 2 questions. Thank you.
Thanks for the questions. In terms of the jacking, it's synchronized. But I think, the 2 jacks actually sit next to each other, I think in parallel. I think they move in a synchronized manner. And also, I think every time when it moves, we had to check the movement and see whether the bridge is actually launching in the right direction. Because if you imagine, I think it's actually launching along that rail. And you can't accept any misalignment to happen, and that will cause stability issues. So to answer your question, it's synchronized, yeah. And then where it sits, it's actually, it sits below the bottom chord. So I don't have the detail here, but I think you probably need to imagine. I think, so you have the horizontal jack sitting below the bottom chord. I think next to the horizontal jack, there is a vertical jack next to it. So you get some space between the bottom chord, the bottom face of the bottom chord and the guide rail, the rail at the bottom. So the jack actually sits in between. But at the same time, when it jacks across there, you have a sort of a sliding pad for the end of the jack to actually push the bridge along. Yeah. Hope that answers your questions. Yeah.
Sorry, total how many jacks? Is it all in the front or at the back?
It's actually, okay, so the short answer to that is I think that the working jack that pushed the bridge along is just on one side. So it's not all of them. So how many jacks? There's on each point, there's a vertical jack with a horizontal jack, and the same for the other side. And then for the other end, there will be the sliding sort of jack that we've got. Because the jack, it actually controls the height of the bridge to make sure, because the bridge is not straight, it's got a kink in the middle. Yeah. So we have to make sure that it's actually sort of, it doesn't hit anything when it goes along. Yeah.
Yeah, I think it's quite similar to incremental launching.
Yeah.
Okay,
yeah.
thank you. Yeah, thank you.
Yeah.
Thank you.
All right. Your second question is Dr. Cheng. So you are talking about this high speed 150 km per hour. To me, 150 km is not a high speed, so still like normal speed. So and then you are concerning on the embankment, right? Yeah, embankment. So far, I mean, if you're using the RSI, everything, you don't see any kind of very huge additional stress on the embankment. So that's why on the embankment, normally there's no RSI requirement. It's only between the interface embankment with the structure. Then you need to check against this interface between this rigid structure and this more flexible kind of embankment. Of course, to me, so far, what we know that actually rail on the rail, the code requirement is they say that the settlement between the one point should be less than 3 mm. So it's more than that. There is a possibility, high possibility. I'm not saying 100%. The rail will break. So perhaps you can check it through the RSI, you model your geotechnical stiffness. And again, we come to this geotechnical boundary of stiffness. The variable is too much. So you have to see how you model this spring value to represent this geotechnical. Of course, that's why where this the boundary change, like bridge and the embankment, this is more critical rather than this uniformly is embankment. So we say that we limit to 3 mm is a maximum, so that we just want to comply with the code. Yeah.
Okay, thanks for the question, gentlemen. Okay. Yeah, please.
Okay, hello, my name is Muhammad Haris. I want to ask to Mr. Adam Abinales, as you are as a senior and experienced engineer, I want to know, you maybe have used another software than MIDAS. What MIDAS offer you in assisting your design, and what is your view on the implementation of parametric design for the structural engineer? Thank you.
Okay, thank you for that questions. I've been practicing in the Philippines for decades already. And when MIDAS was introduced in 2012, I was one of the pioneer users of MIDAS. And I started with the MIDAS Gen for buildings. In 2016, since I have been doing a lot of bridge structures in our country, so I've been using MIDAS Civil in 2016. Although before MIDAS came in to our country, we've been using ETABS, we've been using STAAD Pro, a lot of ETABS and for buildings, and STAAD Pro for buildings and bridges also. Yeah, we just do the line modeling, no? But not as sophisticated as what you can do about using MIDAS Civil. So, well, to your other question, actually we've been, in fact, I was telling MIDAS that if they can come up with the AI feature of their software, because there are some other software developers wherein the AI plus parametric modeling actually is being now integrated in the software. In our country, there are some of us who are into that parametric modeling using Grasshopper actually, and now we look forward to see that most of our software that we are using as a computing tools would have that feature wherein AI. Although it is not something that AI would still be replacing the civil engineers or the structural engineers, because unlike other professions, AI could be something that they can use. But in engineering, I don't think AI should be the one controlling us. It should be the engineers to use this AI to their advantage, but not AI letting them to decide what you need to design.
Okay, another question from the floor.
Hello, good afternoon. My name is Muhammad Hafiz. I just want to address Mr. Adam. What was the main cause for the lateral movement of foundation for 175 mm before even you construct the bridge? Was it a natural forces or something else?
Oh, yeah.
Thank you.
Yeah, thank you for that question, but I don't want to actually discuss the details, but it is something related to the construction, I would say, methodology. It's more on erection sequence. When they are working on this project, because as I have mentioned in my presentation, that the project during the construction was was divided into two phases because of the funds availability. So when they awarded the first phase, which is up to pier, actually to be specific, pier number 8, and there were still 5 spans to be laid out later on. When they did the first 8 spans, there were no issues. But because of the phasing, wherein you do not have the structure on the other side, while working on that span, so that caused the movement. During the construction, it was felt that there was this big, loud snap, or where I don't exactly mean that it is a snap wherein totally crashed, but it's something that there is this loud noise that trigger that movement. So that was the story told to me, because I need to know the details when we were working on the reevaluation of the bridge. So it's not caused by any natural phenomenon. Thank you.
Okay, thanks for the question, gentlemen. I think we can get one more question. Okay, please. After this last question, we can have the lunch break. Yeah.
Okay, my name is Punidana. Okay. My question they're addressing to Mr. Tzyy. Okay, my question is how does the dynamic load from passing train influence the RSI? Maybe we can talk about HSR, high speed rate.
Sorry, can you repeat the question again?
How does the dynamic load from the passing train can influence the RSI? Rail structure interaction, between the structure and the rail,
I think there is a different kind of a consideration, right? RSI never check on the dynamic. So your question is to the dynamic due to the high-speed train, right?
Yeah.
Am I right? I think RSI is not a dynamic analysis. So dynamic, you had to go to this comfort and is another requirement due to this what we call high-speed rail model, SSL 1 until something. There's a lot of model for the high-speed rail. So RSN not dealing with this dynamic. So I think maybe there is no direct linkage between the two. I'm not sure whether this one answer your question or not.
Okay, thank you.
One more, the last one more. Do we have? Okay. What a great set of the questions and answers. And thanks to our speakers for their thoughtful answers. And this concludes our morning sessions. And thank you all for your participation. And we will have the lunch break for 1 hour from now on. Okay. Thank you. Thank you all.
Thank you.
And now, MIDAS Civil has been reborn as a brand new product. Everyone, please prepare to delve into the future of civil engineering as we introduce MIDAS Civil NX. To guide us through this exciting software, please welcome Axel Lee from MIDAS IT to the stage. Please welcome Mr. Axel Lee.
Okay, hello everybody. Welcome to our 2024 Global MIDAS Square in Malaysia. I had the chance to meet a lot of you during the break times in our event zones. So I hope you had a great lunch today. And if you have time after the sessions today, please come to our event zones in order to experience the new softwares that we are currently here to present to you today. So I'd like to introduce myself again. My name is Axel Lee. I'm a technical support engineer at MIDAS, and I'm mainly dealing with our bridge products. The main product that I've been working on is MIDAS Civil, and as well as the planning of MIDAS Civil NX, which I'll be showing you in today's presentation. So MIDAS Civil NX was released back in 2001, and is now established as the world's #1 bridge and analysis design software in the market. Sorry. So before officially starting today's presentation, let me talk about some of the famous bridges in Asia that have been modeled and analyzed using MIDAS Civil NX. The famous Roski Island Bridge, which crosses between Vladivostok and Roski Island, is considered one of the longest cable-stayed bridges in Asia. We also have been active in a lot of places such as Taiwan, Vietnam, Indonesia, Philippines, Malaysia, you name it. In Taiwan, we have modeled the high-speed rail bridge. In Vietnam, we have modeled the longest suspension bridge. In case of Indonesia, we have a project that connects 2 islands. And in China, almost every bridge was modeled and analyzed using MIDAS Civil NX. So a strong presence is already established. And of course, our software had to be used for a bridge in Malaysia. Consider one of the longest bridges in Malaysia and the longest bridge in Southeast Asia, the Sultan Abdul Halim Muazzam Shah Bridge, also considered named as the second Penang Bridge, was also modeled and analyzed using our software MIDAS Civil NX. So I think ice breaking is over. So now we'll shift gears and dive into an exciting journey as we explore the capabilities of our software, MIDAS Civil NX. Prepare to be amazed as we unveil the innovative features and powerful tools that MIDAS Civil NX is a game changer in the industry. So here's the agenda for today. First, we'll discuss the major changes that our software MIDAS Civil has undergone to evolve into MIDAS Civil NX. Next, I will highlight some of the key strengths and explain why engineers worldwide choose MIDAS Civil NX for their projects. Finally, I will introduce one of our most exciting improvements, our new API capabilities that are sure to interest many engineers today. So I think we're ready. Let's get started. So as I mentioned earlier, our software MIDAS Civil has undergone significant changes and is now called MIDAS Civil NX. Our dedicated developers and engineers have worked tirelessly over the past few years to create a completely new version of our software. Today, we are thrilled to unveil the new face of MIDAS Civil to all of you. So this is the new face of the next generation. One of the major changes in MIDAS Civil NX is a newly designed interface. Here are some of the key upgrades that have been applied to MIDAS Civil NX. We have completely changed the user interface with a black color theme trend that is applied to the complete UI of MIDAS Civil NX. We have created a wider workspace, enhanced control, improved search functionality, enhanced graphics, and also vectorize all our icons. Civil NX has revamped the overall design elements, including product icons, labels, legends, and work trees. By vectorizing icons and interface elements, you can now enjoy the software in high resolutions and sharper visuals even on larger monitors. MIDAS Civil NX enhances the representation of tendons and transparency, enabling more detailed structural analysis modeling. With improved graphic elements, verifying reliable results is now easier. Adjusting transparency is pretty simple, allowing for flexible and clear model inspection. Clear tendon representation eliminates component interface, enabling interface-free analysis model review. We also have included what we call the font scale slider. In here, you can easily adjust the scale numbers displayed in the viewports, including the node and element numbers, load values, and results using the status bar. It also allows for unit system specification and changes, conveniently adjusting labels and transparency using the sliders for a more customized and clear display. When conducting an analysis in Civil NX, you may sometimes encounter error messages. In Civil NX, clicking on the error message will automatically locate the error region. And while this structure is pretty simple, this feature becomes invaluable as structures become more complex. Icons of the same category have been grouped together for easy identification. Additionally, a search bar has been added to the tree menu, allowing users to search and view only the desired content. This is especially useful for large bridge projects with complex tree menus, helping users find what they need quickly and efficiently. Also, now you can assign your desired colors to elements and manage them into different groups. Depending on the construction stage or type of structure, you can apply the desired colors, allowing to intuitively visualize and configure through colors. I think it went to the next slide, but the next feature we want to show you is the in-app search feature. I think a lot of engineers here were able to see this particular feature in the event zone. So basically, there's no need to Google anymore anything for a particular feature in MIDAS Civil NX. Since we included this particular in-app search feature in MIDAS Civil NX, let's say, for example, you want to find something related to beam and release feature in MIDAS Civil NX. Before, you had to go into Google, open the internet server, type beam and release, and find the different manuals or tutorials available online. Now, with the in-app search feature, you don't have to do that. Basically, inside the software itself, the in-app search feature will pop up, and anything you want to find, you just have to type it in, and you'll be able to get the different features, tutorials, manuals, FAQs, everything inside within the software. And by just clicking, you can find it directly in the software itself without the need to go into Internet Explorer or Chrome. So now let's move on to the strong suits of MIDAS Civil NX and why engineers around the world choose our software for their civil and bridge engineering projects. So one of the most important features of MIDAS Civil NX is its powerful and user-friendly graphical user interface. The GUI system is very similar to AutoCAD, allowing you to follow the menus from left to right for your work procedure sequence. The work tree menu on the left displays your entire work history, and you can simply drag and drop to make changes to the model. The message window bar shows error messages, making it easy to locate and resolve any issues. The user interface of MIDAS Civil NX is designed to be intuitive and user-friendly for engineers. It features a ribbon-based interface that provides quick access to frequently used tools and allows for customization according to individual preferences. The software also includes a range of graphical tools and features, such as the ability to display results in 3D, interactive graphs that provide real-time visualization of results, and more. MIDAS Civil NX also covers an extensive range of material properties for concrete, steel, and composite structures based on various design standards such as AASHTO, Eurocode, and BS. Furthermore, we offer a user-defined option allowing users to manually enter material properties and consider time-dependent materials for creep and shrinkage. MIDAS Civil NX also covers an extensive database for sections for any particular bridge design, including PSC sections, tapered sections, composite sections, steel sections, you name it. Another powerful feature that is included in MIDAS Civil NX is what we call the Section Property Calculator. The Section Property Calculator, or SPC, is a powerful tool that calculates the section properties of complex configurations effectively and quickly. The calculated section can be readily input into the structural model using the section input function. For example, if you have a complex section model, let's say in AutoCAD, you can bring that particular DXF file into MIDAS Civil NX, and in the section property calculator, you'll be able to bring that particular section into Civil NX and use it, and also get all the section properties from that particular complex section. MIDAS Civil NX also offers automated tools that simplify and streamline the modeling and analysis process of bridges called wizards. The bridge wizards range from basic to high-end bridges, such as balance cantilever bridge, incremental launching method bridges, girder bridges, railways, and cable bridges. For PSC bridge, you can model it with the various construction methods, including FCM, the moving scaffolding method, FSM, incremental launching method, etc. The following is an automatic modeling tool wizard for PSC composite and steel composites. By providing PSC tendon placement by type for PSC composite bridge, complex tendon placement can be easily applied. Various concrete construction loads can also be applied, and construction stage modeling that can implement step-by-step pouring is also possible. For steel composite bridges, information can be entered by utilizing the details found in the working drawings. We provide steel composite tubular bridges suitable for design and offer 3 types of modeling. These type of models include a mixed model of frame and plate elements, an entire plate element, or a tapered bridge model. We also offer the capability for special bridge modeling, to which cables are applied, can also be easily created. The work time can be dramatically shortened by implementing initial models of cable stayed bridges and suspension bridges, including the initial force. For transverse and grillage models can also be automatically generated from the global model that complement transverse behavior of PSC cross-sections. With the transverse model generation wizard, loading and boundary conditions are automatically generated, saving time and reducing potential errors. Another important advanced lever bridge modeling wizard in MIDAS Civil NX is the rail track analysis model wizard. For models with tracks, the user can use the rail track analysis wizard to create the model. The wizard automatically takes into account all the information about the layout, boundary, ballast, and thermal loads, and additionally generates the moving load analysis models referring to the most critical position. In case of resource interaction modeling, you can have several approaches. The first one is on elastic behavior of soils. Here you define the point springs for the pile nodes. Another approach is based on the nonlinear behavior of soils, in which you define the properties of soil layers, and MIDAS automatically generates the nonlinear soil springs. And also, MIDAS Civil NX has spring supports for integral bridges. MIDAS Civil NX also offers the capabilities for performing bridge soil interaction, also called BSI modeling. BSI modeling is an important consideration in the design and analysis of bridges, as it can have a significant impact on the behavior of the bridge foundation and superstructure. In MIDAS Civil NX, the BSI modeling is performed using the soil structure interaction, also called the SSI analysis model. The SSI analysis model allows the users to model the interaction between the bridge and the underlying soil, including the effect of soil deformation on the bridge structure and the effect of the bridge soil loads on the soil. There are also many different kinds of load types that can be applied to the structure itself in MIDAS Civil NX. For superstructure with tapered sections, we can apply beam-centric and pressure loads for wind effects. Sorry, I think the slide went, okay, sorry. And we also have a function called the section temperature gradient, which we can apply the section temperature gradient that can be applied as per code. And there's different design codes are already implemented in the software for ease of modeling. For prestressed concrete bridges, we have a strong, the slide went off. Sorry for, I think we have some technical issues. Sorry for that. I'll continue with my presentation. So for preset concrete bridges, we have a strong tendon property feature in MIDAS Civil NX. For example, you can intuitively check each tendon shape and location from a 3D rendering view. Regarding the tendon types, MIDAS Civil NX supports internal and external tendons, pre-tension and post-tension tendon types. Also, MIDAS Civil NX automatically calculates the tendon losses as per code, like friction losses, creep and shrinkage losses, relaxation losses, short and long-term losses. So another standard feature that MIDAS Civil NX is highly appreciated by our users, it is advanced modeling load analysis, moving load analysis feature. This feature supports various international design codes, including the AASHTO code, BS, and Eurocode, and includes an extensive vehicle database based on different countries' codes. The moving load analysis simulates the dynamic behavior of a bridge structure in response to moving loads like vehicles or trains. This type of analysis is crucial for designing and evaluating bridges, providing detailed information about the bridge response to loads during its service life. In Civil NX, the moving load analysis is performed using the dynamic analysis module. Users can define various moving loads, including their velocity, mass, and dimensions, and specify the path and loads applied to the bridge structure. The dynamic analysis module performs the time history analysis to assess maximum displacement, acceleration, and stress at each point along the bridge. The program conducts influence finite analysis and lane optimization to identify critical position on the structures. Users can display the maximum bending moments or maximum flexure for beams anywhere on the structure. MIDAS Civil NX identifies the locations with the most critical effects, providing detailed insights into the structural performance. We also have a particular feature called the moving load tracer, which allows the users to check the worst effect and corresponding load patterns, helping them visualize and understand critical position and load configurations. In construction of bridges, MIDAS Civil NX offers a powerful construction stage analysis feature. This tool allows you to divide the entire construction process into different steps where you can define the activation or deactivation of elements, boundaries, loads, and element properties. The construction stage analysis in MIDAS Civil NX is a simulation tool used to predict the behavior of a structure during construction. It allows engineers to analyze the construction process and evaluate the stresses, deformation, and stability of the structure as it's being built. This information can be used to optimize the construction methods, ensure safety during construction, and avoid potential structural problems before they occur. The construction stage analysis tool in MIDAS Civil NX is user-friendly and can perform comprehensive analysis for a wide range of structures. During the bridge construction, the construction stage analysis features in Civil NX allows for a detailed simulation of the entire process. If you have to deal, let's say, with composite structures, using MIDAS Civil NX, you can define activation in different stages for different parts of the section. Now we would like to talk about some of the analysis capabilities that MIDAS Civil NX has. So with MIDAS Civil NX, you can effectively analyze a PSC or preset concrete bridges. The software facilitates the effective data generation through automatic creation of taper sections for PSC modeling and automatic rebar arrangement. We also have what we call the tendon generator, which allows you to create tendon profiles using CAD files, streamlining the process of defining the tendon geometry. Additionally, PSC modeling is made easy with the tendon template, which assists the user with the repetitive placements of tendons according to different design standards. MIDAS Civil NX also offers a PSC beam stress function, enabling you to check stress points at up to 10 locations for comprehensive PSC design and analysis. Furthermore, MIDAS Civil NX supports PSC design according to various international codes, including ASTRO RFD and Eurocode, ensuring compliance with diverse regulatory design standards. From modeling and analysis to detailed design, MIDAS Civil NX provides a complete solution for all aspects of PSC bridge design. In the results of construction stage analysis, MIDAS Civil NX provides a Canva result table and graph that are essential for efficient construction. The Canva result table offers detailed data on anticipated deflection and required cambers at various stages, helping engineers plan precise adjustments. The camber result graph visually represents these cambers and deflection, making it easy to understand the structural behavior during construction. These tools enable construction teams to make informed decisions, reduce errors, and ensure the structure meets exact specifications, leading to a smoother and more efficient construction process. Next, I will introduce 3 nonlinear analysis tools in MIDAS Civil NX that are essential for areas prone to earthquakes. First, there is the pushover analysis tool. This tool considers the P-delta effect of piers or column structures, allowing you to calculate the resistance capacity of the structure and compare it with the seismic response. Various nonlinear hinge properties can also be automatically calculated or defined by the user. By converting the design spectrum according to various national standards into a design spectrum, it is possible to evaluate the structure's capacity spectrum effectively. Another critical tool is the boundary nonlinear time history analysis, which is used mostly for bearing calculation. This analysis tool is crucial when considering the nonlinearity of seismic in isolators and seismic dampers in bridge structures. It allows for a detailed assessment of the performance of these components under seismic loads. The third tool is the inelastic time history analysis. known as the most advanced seismic analysis. This method predicts the inelastic behavior of members and determines the seismic response of the structure through a hysteresis model that simplifies the nonlinear characteristics of structural members. Inelastic time history analysis supports a fiber model that can consider various nonlinear materials models of column cross-sections, allowing for precise seismic performance and safety evaluation. These advanced tools in MIDAS Civil NX provide comprehensive capabilities for designing and evaluating structures in seismic regions, ensuring safety and resilience. Sorry for that. Okay, now we'll talk about some of the design capabilities that MIDAS Civil NX currently has. So MIDAS Civil NX design capabilities supports highly reliable design process used in 120 countries around the world. You can proceed with design by intuitively selecting product features. As you can see, we provide various design codes for RC, steel, SRC, composite sections, and PSC sections. For beams, you can basically check and design the reinforcements. And for columns, you can design not only with the built-in database that is currently MIDAS Civil NX, but also with general cross-sections that the user can create, and even check the 3D PM curve. For PSC sections, for PSC design, it supports bending, shear, and torsion design for both PSC-DV and general sections by considering various design variables of PSC. For PSC composite design, MIDAS Civil NX supports analysis and design that reflects the equivalent cross-sectional properties considering numerous rebars and tendons. This includes incorporating slab rebar stiffness during the stage-wise analysis of composite sections, ensuring accurate and reliable design outcomes. Additionally, PSC design is capable of bending, shear, torsion design for composite PSC-DV and general sections. For steel composite design process in MIDAS Civil NX involves several key steps to ensure comprehensive and reliable analysis and design. It begins with evaluating the composite action during the different construction stages and assessing the long-term effects on the composite action using the long-term elastic models for concrete. Next, the main girder is checked for compliance with design standards, followed by ensuring the adequacy of the stiffeners. The process then verifies the adequacy of shear connectors and evaluates the cross frames and bracings for structural integrity. Finally, a comprehensive design report is generated, summarizing all checks and analysis. Lastly, I would like to introduce one important feature which is called the General Section Designer, which is included in MIDAS Civil NX. This is a nonlinear cross-section analysis program for action members or general section shapes. General Section Designer, or GSD, allows for the consideration of various nonlinear materials for concrete and steel. Based on standards such as ASHRAE LRFD and Eurocode, you can calculate the 3D PM curves and MM curves. With DSD, you can check the stress distribution and values considering the nonlinear material properties of the construction. Additionally, you can calculate the moment curvature curve, which is essential for assessing the ductility of the structure. So I think we are now ready for the main course of today's presentation. So finally, for today's presentation, we'll look into one of the major innovations our company is going through and how through API, the paradigm of how engineers will work will change. So we say we are currently undergoing the beginning of a massive shift. So this can be a bit flashy, though we say that we are not wrong. As an example, MIDAS Civil has always been a node and element-oriented tool. But now, with the introduction of the API, you could use any other way of modeling that you are comfortable with. So over the past few years, our company MIDAS has been leading the technology in the engineering field and striving to disseminate better products and technologies to the world. Now with our open API, we have improved automation and analysis performance for user convenience and have advanced related technologies and usage environments to expand and facilitate the work of engineers. These will be the three main innovations that we'll be talking about, and we will start with the design automation. So what is design automation? Design automation is the performance of a process by automatic means, and is especially important in the engineering field, which involves a lot of modification and iterations for optimal design. With our API, we have made possible to the engineer to use MIDAS Civil NX to automate all engineering tasks, from modeling to analysis to output results and drawings. So yes, MIDAS Civil NX has design capabilities, but engineers usually use it for preliminary design. At the end, we just trust our own design sheets. With MIDAS Civil NX API, you can link the design sheet with the models file for seamless data exchange. In fact, you can make your design sheet so versatile that you may not even need to open MIDAS Civil. The level of automation is now completely in the control of the engineer. So this is an example of a PLC box girder using one of their most familiar tools engineers are most familiar with, which is Excel. So basically, you have all the information in your Excel design template, including the section information, boundary conditions, the alignment information, etc. And with the API, you are basically connecting and sending information from your Excel template to MIDAS Civil NX. Any changes that you make into the Excel template are completely updated in your Civil NX model. So here we have another example where we just changed the section of the PSC superstructure, made the different changes of the width and height, and by clicking Create Model, the model is automatically updated according to the information in the Excel template. But in most cases, most civil structural engineers do not know how to code. Therefore, even with the API, with the well-equipped API is well-equipped, they find it difficult to use because they think they need to code. However, customers, most customers using Civil are very proficient with what we call the MCT. The API is not much different from the MCT, but it requires some coding to send data to the product remotely. The Excel add-in is an installation program for Excel that helps send this data without any coding. The Excel add-in is an additional feature for Excel, which will be registered and distributed in the Microsoft Store. So by installing the add-in from Excel, users can also organize data similar to MCT through various formulas in Excel and set it to the product. Users can set up various data separately, group them into a single group, and make them operate sequentially. So in this particular example, we have a simple beam model in MIDAS Civil NX, and in Excel, we have installed our plugin, Excel add-in plugin. And in here, we assign, basically connect the API key with MIDAS Civil NX. And once that connection is established, let's say you would like to export some tables, result tables or images directly from Civil NX to your Excel sheet. You will be saving that particular table in Civil NX. save it as a dynamic, let's say, table report with all the information that you like for moments, forces, etc. And also, let's say, save the image for beam image. And you assign the sheet where you want this particular report or image to be included. Select which type of list you want to include. Add to the folder. And once you update it, you will have that same report directly that was created in Civil NX into your Excel template. So nowadays, it is possible to run MIDAS products by directly creating a Python code, which is receiving a lot of attention by a lot of engineers today. The example you see here was created not by a developer, but by a regular practitioner. And it demonstrates the optimal design of steel structure. By writing a code for steel optimization with the API, the Python code will run as MIDAS Civil NX performs iterations to find the most optimal solution according to the algorithm set in the Python codes. So basically, with the Python code here, once you run the Python code, Civil NX will perform all the iterations to find the most optimal steel section for your structure. Again, parametric modeling has also been a hot topic among engineers, revolutionizing the way we approach design and analysis. By leveraging the API, we can now integrate visual programs such as Rhino and Grasshopper with MIDAS Civil NX to perform parametric modeling, allowing for more dynamic, efficient, and optimized modeling workflows. The integration provides three main benefits. First is flexibility, by allowing engineers to modify design parameters in real time. Automation, by streamlining repetitive tasks and enhancing productivity. And optimization, by performing iterative analysis and refining design for optimal performance. Let us look at some examples of how this is done. Let's say you have an existing detailed design model in MIDAS Civil NX, and you can create a simple script linking the curve in Rhino to the existing model in MIDAS Civil NX. So once that connection is established, you can modify the curve in Rhino with simple clicks, and immediately the model, along with the loads and pre-stressing, boundaries, everything will be updated to the new layout. So in here, we changed the layout in Rhino, made the appropriate changes in Grasshopper for the parametric modeling. And once that change is made, you can generate that particular model in Civil NX. And what is important here is all the loads, all the boundary conditions are also taking the alignment information. This is another example in which Grasshopper plugins developed from MIDAS are within Grasshopper and being used to perform parametric modeling using Grasshopper and MIDAS Civil NX. So currently, our company has finished developing some plugins for Grasshopper that have all the information for that Civil NX has, for example, for the section database, material database, etc. So here we are generating or modeling arc bridge using Grasshopper plugins developed by MIDAS. So you can also create the load cases, assign the loads, and all those, the different MIDAS plugins inside Grasshopper have all the information from MIDAS Civil NX. So some of you might think that using the program's UI is still more convenient. That is, it will be great if dedicated functions and UIs for performing various tasks could be added quickly. So we have implemented a plugin service that can be downloaded and used just like a mobile app. As mentioned earlier, with the MIDAS plugin service, you can download and install the necessary plugins like mobile apps and use them directly within MIDAS Civil NX. You can expand and use various convenience features through the use of our different plugins. Unlike before, the plugins are continually being updated online, allowing you to utilize new features. Features. In the future, numerous plugins will be updated by ourselves, MIDAS, or by external developers, or by the customers themselves. So let us look at some of the few of the available plugins that are currently available in MIDAS Civil NX. So we'll be first looking into the alignment generator plugin. So we know that a lot of engineers, let's say, don't know how to use Grasshopper or Rhinoceros. Then they will be using our alignment generator plugin, which is basically a plugin that helps you generate different alignments. So here you'll be downloading, let's say, the particular plugin in Civil NX, and this will be the different information that you'll be inputting in order to create the alignment. So you'll be creating the different segments for the alignment and the line types. If you want to be straight, if you want some radius for the alignment, or you can also input those kind of values. And once all the information for the alignment is set up, you just have to click Create. And the alignment with the beam element or the model with the alignment information will be automatically generated from the plugin. Let us look at another example. So this is the Flare Peer Creator plugin. It's the same. This particular plugin is very simple. Is to create substructure for your superstructure, and basically you select the nodes, the reference nodes of the bottom of the bearings. Select those nodes, and you will select the section, the materials, the length of the superstructure, the substructure that you want to be placed. And once you click Create, you can easily create pure caps or substructure model. I have only explained a very small portion of the plugins that have been developed so far. As mentioned before, we will make a plugin marketplace where not only will we be developing and uploading plugins, but users will be able to create their own plugins and upload to the marketplace so that other users can use and, of course, get paid for them. So until now, I have explained, introduced the innovation that eliminate the limitations of MIDAS Civil NX feature and users' environments. But yes, by the end of next year, we'll be replacing the solver, which is considered the heart of MIDAS Civil NX, revamping the analysis engine. The next generation solver will be able to apply tendons to 2D plate elements or solid elements. Therefore, it will be possible to analyze structures such as PT slabs in the construction field. Additionally, it allows for analysis by case. After modification, let's say you run the analysis, you need to make a modification of something, and you want to just run the analysis for moving load analysis, you will be able to do so with the new solver. So this is all for my presentation today. We hope that through MIDAS Civil NX, we aim to make the engineers' work or civil engineers more efficient and faster. We at MIDAS IT will continuously research and develop to innovatively improve the working environment of engineers. So everybody, get ready for a powerful move forward. Thank you very much.
Please give a big hand for Axel Lee. Okay, thank you, Axel, for the comprehensive look at Civil NX. Thank you. As you can see, it's far more than a simple upgrade. I'm sure it's a completely new product with a fresh user interface and a host of powerful features. If you want to explore Civil Annex more in detail, or if you're curious about the components and cost of the product, you can visit the consulting zone on the backside and ask for the consultation. What I heard is that there is a special offer today during the seminar is waiting for you. Okay. For the next session, we have an introduction of MIDAS collection. You know what? MIDAS is committed to prioritizing our existing customers. That's why we are thrilled to announce the launch of a new service package, the MIDAS collection. Mr. Connor Kim will share the details of this exciting offering. Please welcome Mr. Connor Kim.
Hi, nice to meet you. My name is Connor from MIDAS IT Korea. So it is a great honor to meet you here today, and I appreciate your attendance for today. And maybe you already know me. I was there at the Civil Engineering Experience Zone. So thank you for your active attendance for today. So in this presentation, I'm going to introduce our brand new service, which is MIDAS Collection. Shortly, we call it M Collection. So this figure shows how M Collection consists of. So with Civil Annex, we have 3 different software. So which are CIM, FENX, and CAD Infra Design, CAD ID. So especially here in Civil Annex, we allow to use API and plugin functions. So it means now you can increase your possibilities in your modeling and analysis stages. And it means like we can increase, we can overcome the previous limitations what we had from using previous MIDAS Civil. And we also renovated our technical and training services from our new websites. So in M Collection, as I said, we have 4 different design tools. So CIM is a good 3D modeler especially for the bridge structure, and good connector between MIDAS software. And this FENX is FEM software for more detailed analysis. And this CAD ID is 2D drawing software, which contains 3D information. So when you have your 3D modeling in CIM, you can easily send your model to Civil Annex for global analysis. And you can, of course, you can send it to the FENX for more detailed analysis, what I mean FEM analysis. And this CIM and CAD ID are interconnected together. So it means when you have your 3D modeling in CIM, you can extract the 2D information, I mean the 2D drawings, directly into your CAD ID. And when the good thing is when you update your 3D modeling from CIM, then the updates are automatically applied into your CAD ID. And we also newly released our new website, MIDAS Support and MIDAS Academy website. So this is the M Collection service. I can say it is all-in-one solution for civil engineers. So in the next part, I'm going to introduce our design tools more in detail. So I'm going to start from the Civil Annex, but we already covered this Civil Annex from the previous presentation. So simply it has API and plugin function to increase, it means you can increase your flexibilities in your modeling and analysis stages. And we also upgraded our user interface to increase your workabilities. And of course, there is an in-app search function. And we are also planning for the AI services for your technical questions. It means in the near future, hopefully you can ask any of your technical questions to our AI in the Civil Annex. So next software is a CIM. So CIM, I introduced this is a good 3D modeler especially for the bridge structure and good connector between MIDAS software. So whenever I heard 3D modeling, it sounds very, very difficult. But you don't need to worry about this because here in CIM, we have smart template. So using smart template function, you can design your structure very easily. So you can just type the basic information of your structure, then this CIM help you to create those structure very easily. So we have many design templates such as PSC, FCM, FSM bridges, and cable state and suspension bridges. Of course, we have a tunnel structure. And also we have many libraries for the elements. So you can utilize this smart template function and libraries together to create your own structure. And this CIM is really specialized design tool to represent the curvature of the structure. So for other 3D modeling software, they are like more specialized for the building structure, which is completely linear, I mean the straight. But most of the cases for the bridge structure, those are not completely linear. So CIM is very special tool to represent those kind of features of the structure. And as you can see here, we have many different functions to represent the characteristics of the bridge structure. As you can see, such as rebar and tendon and stiffener, something like that. So that's why I introduced this CIM. It's really specialized tool for a bridge structure, and I recommend to a bridge engineer for this CIM software. And as I said, CIM has great compatibilities between MIDAS software. So I will show you why. So this is the video from the CIM to the Civil NX. Oh. Sorry. So can you learn this video? Sorry for that. So actually, whenever you have your 3D modeling here in CIM, you can easily send your file to the Civil NX for global analysis. So you can basically you can send entire model, or you can select the specific parts of the structure. So before you send your model from CIM to Civil NX, what you have to do, you can set up all the boundary conditions from the CIM side. And what you have to do here in Civil NX is to apply the analysis or the load cases, whatever you want. All right, it's fine. So this is the video from CIM to FENX. So this CIM and FENX are both 3D based. So you can easily send your CIM model to FENX for FEM analysis. So after you send your 3D model, what you have to do is apply the meshes and boundary conditions and the load cases, whatever you want. And of course, we can also send this FENX file to the Civil NX in this way. So whenever you look at these 3D meshes, whenever we consider the opening of the structure, it is almost impossible to create it directly in Civil NX. But if we utilize this CIM and FENX together, we can easily create these 3D meshes and send it to the Civil NX. And as I said, this CIM and CAD ID are interconnected together. So this is the example for that. So if you have your 3D modeling, then you can extract the 2D information, I mean the 2D drawings, directly into your CAD ID in this way. So as I said, whenever you update your 3D modeling from the CIM side, then the updates are automatically applied in CAD ID. Based on my experience, whenever I communicate with drafter teams, actually it was really time consuming and difficult, because whenever I share the updates of my structure, such as the rebar or the tendon, actually between me and the drafter team, there was frequent miscommunications, and the result was not the same as I expected. But if we share the result of the CAD ID, then we can minimize those kind of errors. Yeah, actually this CIM is 3D modeling software. That's why they allow to import and export IFC format. And IFC format is most common format for 3D modeling software. So when you have any 3D modeling software from other design software, then you can bring it to the CIM, and you can send it to the Civil NX for global analysis. And of course, you can send your 3D modeling from CIM to other 3D modeling software. And now I will look at FENX. This is our FEM software. You know, there are many situations we require to conduct more detailed analysis, such as soil structure interaction or stress and fatigue analysis for connector or joint, and contact analysis or concrete cracking analysis. And this is the application, how we can use FENX in your work process. So this is the steel structure from the top right part. And sometimes we want to check more detail for this connector part. In that cases, whenever you look at the 3D meshes over there, it is almost impossible to create it directly in Civil NX, right? But whenever we use FENX or the CIM together, we can very easily create those 3D meshes and put it into your Civil NX. And this is the diaphragm or pile cap or pier cap, such kind of like stress concentrated zone. Sometimes our contractor can ask us to conduct more detailed analysis. Of course, from Eurocode or Ashito, they ask me to conduct strut type model, but that is 2D based, right? But sometimes we want to check more detailed analysis in 3D basis. So in that cases, we can use FENX together with. And now, in the next part, I'm going to introduce our renovated services we have. So as you know, we keep providing local training for the engineers. So if you have any good idea or request for the local training, then you can ask to our sales team. And our sales team can set up for the future local training for you. And of course, in the future, we MIDAS IT will more focusing on the M collection services, how our user can utilize these M collection services, such as Civil NX or CIM and FENX, something like that. And this is our new technical website. Can you run the video? Okay, cannot. Okay, so in this MIDAS support website, there is a Ask AI. So in the Ask AI, you can ask any of your questions regarding to the installation and licensing issues. So whenever you face such kind of difficulties, such as installation and licensing issues, you can directly ask to our AI services. So when you ask any of your question to our AI, then our AI give you the answer in the text format first, and after that we also give you the video. So the good thing is, if you are not good at using computer, you can just solve your problem while watching the videos we prepared. So as I said, in the future, in the near future, we are also planning to develop the technical GPT services. So in Civil NX, hopefully you can ask any of your technical questions directly to our AI services. And here in MIDAS support website, there are many technical documents we have. And here on the bottom side, we have API manuals. So if you have any, if you want to try to create your own API and plugin in the future, so you can watch these manuals. And of course, you can ask any of your questions regarding to the API or the plugin directly to our engineer. So there is a special section for the API queries. So you don't need to worry about to create your own API or plugin. And this is our new Academy website. Here in MIDAS Academy website, there are many courses we prepared. And here on the bottom, there is API courses as well. So you can study by yourself while watching these API courses and to get an idea for the future API and plugins. And if you have any good idea for the API or plugin, you can share with us, our MIDAS IT team. Then we can collaborate together to create the future plugin and API together. And of course, here, when you complete each of the courses, then we give you the certificate in this way. So this is connected with your LinkedIn, so you can share your experience with others. Yeah, so this is the M collection service, what we prepare for today. So hopefully in the near future, you will enjoy these M collection services with other design tools together. So thank you for hearing today.
Around a big applause for him, Mr. Connor. Thank you. All right, thank you, Connor, for the enlightening presentation. The MIDAS collection is designed to provide our valued customers with comprehensive support, training, and resources to maximize their use of MIDAS software. Okay, let's begin the talk show, afternoon session. Welcome to the MIDAS Tech Talk Show. Let's chat with Mr. Connor, Mr. Axel, and Mr. Joseph. Hello, everyone.
Hi.
Hello.
Yeah,
Hello.
Hello. Okay, Connor, I heard you were super busy in May with over 20 meetings with clients. Tell us about it, please.
Actually, I had a lot of meetings with Malaysian or Singaporean and Australian users. For this M collection things. So it was really good time, and I got some very great insight from there.
Oh, then you must be able to speak in Malay now.
Actually, yesterday I practiced one sentence.
Can you show it?
Okay, I will try, but I'm not so sure about it. Hello, aku Connor. Aku cinta kamu.
Aku cinta kamu. Okay. Well, what does it mean?
It means, hi, I'm Connor. I love you.
I love you.
But I'm not so sure about it. It is correct.
Yeah, so you love them, right?
Oh yeah, of course. They are really kind of, especially for Malaysian engineer. They are super kind, and they are really specialized engineer.
Oh, you feel in the same way with me. Yeah. Okay, got it. Okay, so Axel, this is your first time to visit Southeast Asia?
Oh yes, it's my first time basically here in Southeast Asia. Yes. And
So how did you feel?
I think Malaysia is a very beautiful country. For example, for me, when I was in my undergrad studies in the States, I really wanted an opportunity to see the Petronas Tower here in Malaysia. But after coming here to Malaysia and being able to see the Petronas Tower is because it's right besides the KLCC
it's so beautiful.
Convention Center.
Yeah, it's so beautiful.
And I think there's a spot where you can take a really beautiful picture of the Petronas Tower. I think that experience is, as an engineer, to see such a structure with your real eyes in person. I think that's a very unique and very special experience.
Yeah, good to hear that. I hope you enjoyed the last days here.
Thank you very much.
Okay, Joseph, I saw you were taking charge of the experiencing John there. How was it today?
Yeah, so it was a great experience. So I got the opportunity to interact with the brightest minds in Malaysia. So that was an incredible experience. And I was able to explain the different capabilities of CIM to various participants. So overall, it was a great and wonderful experience. Yes.
Whoa, okay, very good, very nice. Okay, so I think now we can start. Right?
Yeah,
okay,
sure.
All right. So from the beginning, question number 1: what type of structure is MIDAS Civil Annex specialized for?
Actually, I can answer for this question.
Okay.
So actually, MIDAS Civil Annex is commonly known as very specialized software for complex structures, such as bridge structure. Of course, it is true because we have many advanced features, such as construction stage analysis or nonlinear analysis, for moving load analysis, something like that. So yeah, that is really good for good software for complex structure.
So it's kind of versatile software, isn't it?
I'm sorry.
Versatile software?
For
various software, right?
Yeah, actually, yeah, you know, however, like MIDAS Civil NX has like very versatile software itself, because starting from the simple structure, such as like underground structure, to complex structures, such as PSC bridges, we can modeling everything using the Civil NX. So that's why I recommend the Civil NX to all the civil engineers for various type of the structure.
Okay, can we move on to the next question? Okay. What is MIDAS CIM specialty from other 3D modeling software?
So when it comes to CIM, CIM is a software which is specially designed for bridge engineers. So majority of the softwares which are available in the market right now, that is the BIM softwares, they majorly focus on vertical structures, such as buildings. But CIM corely focus on bridges and the alignment-based structures. So it is quite easy to model the complex curves in CIM. And then apart from that, we have smart templates. So the users who might be using Civil, they might be familiar with the bridge wizards. So it's quite similar to that. So we just need to enter the parameters and automatically the bridge gets modeled. And next, we have different features such as rebar modeling, tendons, stiffness, and bolts. So using all these features, you would be able to model different members of the bridge. So all these features make CIM a unique software.
Thanks for your answer, Joseph. Okay, it's a bit practical question. For software such as MIDAS Civil NX and CIM, training and tutorials are very important for engineers or engineers working at a company to start learning and get used to the software. Does MIDAS provide these kinds of training and tutorials? Yeah, it's really sensitive for the customers, right? Okay.
Yes, I think I can answer this particular question. So yes, MIDAS, our company MIDAS is very well known throughout our customers for the different type of trainings and tutorials and materials that we have currently online. For example, we have an academy site online for our users, where users can come in and learn and let's say see contents. And those contents are not just any contents. Those contents include contents for beginners, for intermediates, and for advanced users. So any users, let's say if I'm completely new to MIDAS Civil NX or CIM, they can come to our academy site and they can start seeing, let's say, the beginner tutorial videos. If they are, let's say, kind of used to our software, then they can take some of the intermediate or advanced courses. In terms of online trainings or hands-on trainings, our company is also well known for that. If different companies ask the sales managers for some kind of hands-on trainings, then we schedule this kind of trainings. It can be online, or it can be by coming here to, let's say, if a lot of companies here in Malaysia ask for a hands-on training, we might do, let's say, like an MBM, where we can, and technical engineers can come in and do some hands-on trainings regarding our software itself. And one thing I want to add here is the online support that our company is really famous for, and a lot of customers or users of our software are really happy with, is the online support that we give our users. And let's say we have I think we have a global technical support site where our engineers, global technical engineers, will, if a user uploads a question or a query regarding the usage of our software, then our support engineers will answer that question in less than 24 hours. So yes, so in terms of that, I think we have pride on that in terms of the support that we give our users and engineers when they have problems with our software.
So we do provide with the online and offline support and training.
Yes, we can do online thing. Mr. Connor has been in some online trainings as well as some on-site trainings. And as Mr. Hiro mentioned, if
if let's say you need some urgent support, then we can assign, have an, like can say, an online meeting with our sales manager as well as our technical support engineer. And as I mentioned before, if a particular group of engineers from various companies need a hands-on training in a particular country, then we are more than happy to come here and train the users.
Just out of curiosity, how long will it take to become professional users of MIDAS product? If, let's say, I'm a beginner, how long will it take?
I think there's not a time. I think you cannot measure that as time.
Yeah,
I think the longer you use the software, the better you get. But I think you have to go into deep to every single, let's say, feature of the software itself to be more proficient to it.
Okay.
So yeah. So
Thanks
I
for the
think,
answer. Yeah,
but
okay.
of course, looking into the different contents that are already available online will also help you boost and start lift you with the beginning to know and learn the software.
That's the critical points. Yeah, okay.
That's right.
Yeah, can MIDAS CIM be integrated with other 3D modeling software? I think it's the question related to the interoperability, integration with other software, right?
Yes, like as CIM is in the BIM space, so interoperability with the different other softwares is required. So basically, we achieve the interoperability by different methods. So for example, that could be either using IFC file or using Parasolid file or DWG file. So once you create the CIM model, you would be able to export the CIM model into the different formats which I mentioned earlier. And then you would be able to import those files into the different other softwares. And then apart from that, you might have experienced the contents which were available in the VR zone. So in that particular VR zone, what we did is we have created the model in CIM, and then later on we have exported it to the VR software. So you would be able to achieve interoperability by different methods, and it's up to the user to choose which method he prefers. Yes.
Okay. Does anybody wants to say more? No? Can I skip it? Okay, good.
Clear.
Okay. Next question is, we don't have our development team. How can we manage for API and plugin? Oh, yeah. Can somebody answer it?
Yeah, actually, I think I can answer for this question. So actually, from the booth, I heard many of these questions regarding to this one. So actually, in my understanding, I understand that there are most of our most of our clients don't have their development team in their companies. So that's why we MIDAS IT keep providing the valuable plugins or the APIs to the users. And also, we are continuously communicating with our clients to have a future plugin item. So of course, like for the clients, you can create your own plugin or API in the future, because as I said, we have many contents from our new websites, such as MIDAS support website or Academy website. So you don't need to worry about that. We have many examples for that, so you can use it to create your own API or plugin in the future. Of course, if you have any good idea for the plugin in the future, then you can share it with us. Then we can collaborate together to create good plugin in the future. So I can say, don't worry about that.
Don't worry about it?
Yeah, of course.
Okay, it's not that difficult that as I expected.
Yeah,
right?
actually, engineer also can create their own API and plugin. So it's not so many problems.
Okay, understood. Okay. Next question, please. What if I don't know how to write Excel VBA code?
I think I can answer this particular question. I think during my presentation, I mentioned about the Excel add-in. The Excel add-in is basically an add-in in Microsoft Excel, so a plugin, let's say, for Microsoft Excel. And for that particular Excel add-in, you don't need to know any sort of coding, because as I mentioned, just like MCT, you just assign in the Excel add-in what kind of information you want to send and what kind of information you want to extract from, let's say, MIDAS Civil and X. As I shown in the video and in the event zone, The Excel add-in, let's say you want to extract, let's say, perform an analysis and then extract, let's say, the beam diagrams, get some screenshots of the beam diagram results, and also extract the tables from MIDAS Civil into your Excel template. Then you can do so with the add-ins, and that doesn't require any sort of VBA coding. So I think that's a method on how you can use the Excel add-in and not use the VBA code if you don't know how to write code using VBA.
Yeah, so it's very useful. You can manage everything using this Excel design template. You can manage everything from the modeling stages and until the end. As Axel said, we can extract the data, whatever you want from the Civil Annex to Excel design template. It can be the table format, or you can extract some specific value, such as like maximum bending moment or maximum shear forces, or whatever you want from the structure.
That's a good news because most of the engineers are familiar with the Microsoft Excel, right? So yeah, it's a good news, definitely. Okay. Yeah. How can CIM enhance the workflow and efficiency for structural design consultants and contracting firms in bridge projects?
Okay.
Yeah.
So CAM can be used to achieve the workflow, or it can enhance the efficiency of the workflow, and it can streamline the process between the contractors and the design consultants. So in CIM, you would be able to create the 3D model so that it shall help us to visualize the bridges. And then from that 3D model, you would be able to generate the drawings. And then once these drawings are generated, you would be able to, in those drawings, you would be able to create the rebar detailings and the barbening schedules. Also, you would be able to extract the quantities of the materials, such as concrete, rebars, or steel, using CIM. Also, you would be able to perform the clash checks. So you would be able to identify the clashes very much earlier in the initial planning stage itself, and then you would be able to resolve those clashes very earlier in the project. So by using all these features, you would be able to reduce the error and increase the project accuracy. So this is how you would be able to increase the efficiency and achieve a streamlined process between the design engineers and the contracting firms.
Okay, thanks for the answers. It seems to be clear for now. The next question is, while exporting the model from CIM to Civil Annex for analysis, how will CIM determine the element type, such as beam or plate? This is the question from the floor just before this session. Can somebody answer for this?
Okay, so when it comes to the exporting the model from CIM to Civil Annex or Civil, so basically when we model the CIM, you can define the type of members in CIM itself. So for example, if you can model the member as a beam element, or you can model the member as a plate element or a truss element. So based on the members which we define in CIM, once we export the member to Civil, that particular element property would be reflected in Civil. So this is how we achieve the interoperability between CIM and Civil.
Okay, so it means you adjust some elements in CIM, it will be reflected in Civil as well?
Yes, you're absolutely right. So for the properties that you give in CIM would be reflected exactly the same in Civil.
Okay, got it. Do you have any further questions for this? Nobody has? Okay. Let's move on to the next question. How does MIDAS collection software works in a network environment with a team of designers and collaboration of design team?
Yeah, I think I can answer for these questions. It is regarding to my presentation previously. So actually, we have 4 design tools in the M collection. So starting from the CIM is a 3D modeler. So when you have your 3D modeling from the CIM, as Joseph said, we can easily send it to the Civil Annex for the global analysis. And you can also send it to the FE Annex for more detailed analysis, which is FEM analysis. And as I said, this CIM and CAD ID are interconnected together, so you can easily extract the 2D information of your 3D modeling into your CAD ID. So you can communicate with the CAD ID result with your drafter team. Then, based on my experience, you can maximize your work process between analysis team and drafter team. So in this ways, you can communicate with other teams using this M collection flexibly.
Well, I cannot understand fully. I cannot fully understand. So does it mean 4 different software are all included in MIDAS collection?
Yeah, actually, 4 different software are included in M collection. So you can.
That's why you name it collection.
Yes, right.
Like a package.
Yeah.
Okay, I got it.
So that's why we call it M collection.
So CIM and Civil NX,
CAD ID,
and FANX. These 4 programs are included in MIDAS collection.
Yes, right.
Okay, got it. I think this is the last questions from the floor. Does anybody has another questions, further inquiries or something else? Nothing more. All right. Okay. That was the informative talk show ever. Now it's the time to wrap up this talk show session. Okay. Thank you, Connor, Axel, and Joseph. They were excellent questions and insightful answers. Please give around a big applause for these presenters.
Thank you.
Thank
you very much.
Yeah. Thank you. Yeah. Okay. All right, everyone. The moment you've all been waiting for, the lucky draw time. Get ready for some serious excitement. It's time to find out who's taking home our amazing prizes. The prizes are secret. Is it secret? Yeah. We have 3 kinds of the gifts for the lucky draw winners. We have iPad and Logitech mouse and keyboard combos. So let me choose the lucky draw tickets on the stage, right?
Yeah, we'll do that, yeah.
Okay, let's go. Whoa. Okay.
Okay.
Lucky draw, yeah.
Okay. Hello, East Malaysia, Kota Kinabalu, Kuching.
What is that?
Because there's some other engineers who attended online. So I
online,
just
okay.
say hi to
Yeah.
Kuching and
hi,
Kota Kinabalu.
online participants, hi.
Yeah, hi.
Okay. Yes, the tension is building. Yeah. Who will be the winner of our lucky draws? Just should I choose one? Okay. From 1 to
1 to 5.
No. I mean, how many tickets have we distributed? 90. Okay. Now we have 90 persons who are qualified for the lucky draws. So let me choose one. For the for the 3rd place winner. Random choose. Make a drum roll, please.
Make a drum roll.
No drum roll? Okay.
How much?
The winner is number 6.
Where's number 6?
Who's number 6? Please come to the stage.
Come to the stage right now. Come up to
Please come to the stage. The winner is number 6. Who is this gentleman?
it?
Yeah.
Is it
Okay,
six
number
or
6.
nine?
6. It is 6. Definitely.
Okay,
Yeah,
okay,
6. Yeah, please come to the stage. Okay. Can I have your name?
Leo,
Leo from?
Kuala Lumpur.
No. I mean, your organization or company or?
Mecca Ferry.
Mecca Ferry.
Is a supplier for engineering materials for civil and infrastructure and geotechnicals.
Oh, so Leo from Mecca Ferry.
She takes
Okay, congratulations, Leo. And how did you feel today?
Yeah, it's good. Fruitful, yeah.
How was it? How good?
It's very good. Undescribable.
Okay, thank you.
Maybe should we make him to pick up the next one?
Oh, okay. Leo, please, come to the stage again, please.
Maybe you can pick the next one. The next
Can you
winner.
choose the next winner?
Drum roll. Where's the drum roll? Close your eyes. Take a picture. Okay.
Photo time, sorry. Photo time.
Yeah, for the record.
1, 2. Good, okay.
Okay, close
Can
your
you
eyes.
choose one, Leo?
Close your eyes.
Yeah. Randomly choose. Do not pick your friend, okay? Yeah.
So the number is?
Okay, so the number is 83.
Where's 83?
Please come to the stage. Winner by 83.
Thank you, Leo. You can go back.
Again, gentlemen, again. Congratulations. He is definitely number 83.
Okay. Interview.
Can I have your name?
Chong from BBR Construction.
BBR Construction.
Chong from BBR Construction. Oh, okay. Okay. What do you do?
I'm a design engineer.
Design engineer for?
For bridge and building.
I think he used
Bridge and building.
civil. He's a civil user.
Okay, civil user. Okay. Thanks for coming here today. How did you feel? How did you experience our event zones and any consulting zone?
Have you tried the VR?
Yeah, I tried VR already.
Was it?
Quite impressive, yeah.
Okay,
Even the handrail can be modeled.
Okay.
It was impressive, right? Okay. Thanks for coming today and congratulations again, Mr. Shang.
Should we take pictures together?
Okay. Smile. Okay, thank you.
The final winner.
The
who should we
final
pick?
winner.
Who's gonna pick? Maybe Adam, because Adam is the one who.
Okay.
Thank you.
Congratulations. Have a good one. Yeah. Congratulations.
You'll be the pick. 이건 알려줄까요? 뭔지 알려줄까요? And actually, the last prize is. What is it, Hero? What is it? What is this?
Our first prize is iPad.
What is
iPad?
this?
Am I right? Okay.
What is this?
I'm really curious who's going to take this home, okay?
I think so.
Yeah?
Who's gonna pick the number, the lucky number?
Let me do it like, I'm gonna pick one number and then minus one.
Minus one?
Yeah, can I do it? Pick
For the winner?
For the winner. I mean, when I choose number 6,
how
the
about
winner
this?
be number 5.
You think about the number,
Yeah.
and I think about one number.
Okay.
And minus.
Yeah.
You give it to the number. So
it's kind of a math question.
A minus B.
Yeah, it's too difficult.
Too difficult.
Yeah. Okay. Just let me choose one number.
Okay.
For the clear.
Okay.
Decisions. Please mix it up. Yeah. If I choose my number, can I take it home?
Nah.
Okay, let me choose.
Where's the drum roll?
Can you make a drum roll, please?
Big
drum
one.
roll.
Wow.
Whoa, 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 whoa.
Wow. This
Wow.
number.
2 figures. Okay.
Oh, that's good.
50.
Actually, want to take it.
50. Number 50. Nobody? Who is number 50?
Whoa.
Come on, ladies, to the stage. Wow, 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 wow. iPad winner, MVU. Who is this young lady?
Okay.
Okay, number 50, right?
Thank you, thank you.
Okay, who is this young lady? Can I have your name?
Yasmin,
Yasmin? Yasmin from?
CNO Technique Lead.
CNO Technique.
Cyano Technique.
Cyano
Also our
Technique.
user.
Are you also the civil engineer?
Yes, yes.
What kind of structures or the bridges do you in?
Bridges and temporary work structures.
How was it? How was the presentation for today? Was it informative to you?
Yes, and very impressive.
Impressive. And did you enjoy the VR zone or experience zone today?
Yeah, but it's kind of triggering my motion sickness.
Okay. Okay. Thanks for coming today and really congratulations for your winning prize. Thank you.
Pictures together.
Yeah, picture.
Maybe you should put it.
Thank you for coming today.
Thank you.
Have a good one. Thank you. Okay, for today we had 3 winners for the lucky draws, but I'm expecting we can do this kind of events more and more frequently, and then we can meet more winners someday, right? Okay. For now, ladies and gentlemen, now I'm sorry to say, but it's time to say goodbye. So to bring this inspiring event to a close, please join me in welcoming Logan An, MIDAS IT's Regional Manager in Southeast Asia, for our closing remarks. Please welcome Logan An to the stage.
Hi everyone, my name is Logan. I'm the Regional Manager of Southeast Asia for MIDAS IT. Thank you all for coming. Today we had an amazing conference. One of the biggest that we've ever had in Malaysia. I am so proud and glad that we could hold and arrange this conference in Malaysia. It was the second country after Korea that we had. So we had MIDAS Square in Korea, and this is the second place we had. Hopefully we'll launch more of these amazing big conferences for the engineers in the world. So thank you for making this possible and for your continued support and trust in MIDAS IT as we grow together until today, and we will not stop growing. So before we close the event for today, I would like to ask, why are we here today? So why did you join the seminar? And I'm sure everyone might have slightly different answers, but I believe that the core reason is the same. We all joined. Firstly, we want to learn and see how the engineering community is evolving and how we as engineers can develop and grow expertise. We know that knowledge is power, and with new knowledge, we can achieve great success and also get the rewards that come with these great achievements. Secondly, we know that sharing this knowledge would help us all grow together and bring great innovations to our world. This is why shared knowledge through a community helps us achieve things that were beyond our imagination. But in the end, we pursue growth and push ourselves daily to become better. Why? Why do we always want to become better and develop ourselves and grow? I think this, whatever the reason, this is because we want to be happy. Whether we want to design the most beautiful and magnificent bridges, whether we want to become the best engineer in the company or the best engineer in the country, whether we want to leave a legacy for our children, all this is because we want to be happy. So let's do that. Let's be happy together. Let's build a happy community. Let's together build a safe and happy tomorrow by starting today. We, MIDAS IT, as a solutions provider, We'll continuously be an engineering community for our clients and our industry. We will continue pushing ourselves to provide the best service for your success and to continue building an innovative engineering community. Let's continue to grow together to make the world a safer and happier place. I will conclude my remarks today, and I hope that you can remember and the experience that you had, and you go back home happier, and I wish you all the best. And I hope to organize more seminars like this, and thank you for your continued trust and support. That is all I have for today. Thank you very much for making our event possible, and see you all again very soon. Thank you. Thank you very much.
Okay, Logan, thank you for reminding us that happiness isn't a distant goal, but something we can find in the everyday moments. It's a powerful message that will stay with us long after this event. Okay, thank you again for being a part of this special day for everyone. It's been a pleasure hosting you at MIDAS SQUARE 24. We hope you had a wonderful time today.